Shall I get underway? Okay, you've probably all been reading my notes for the first slide. Feel whenever you put something up and then wait to put up the slide, that's what happens. So I'm going to tell you a little bit about the background to how we came to get these data, what's available now and what will be available in the future. And towards the end, if I have enough time, I'll talk a little bit about the Minnesota Population Center's plans to do some linked data sets. At the moment, we're not funded to do a complete series of linked data sets. We've got some money to do the 19th century data, but the 20th century data, which in some ways is the richest, is not quite on our radar formally because we don't have the money. It's certainly an informal goal. So what is available now is the entire US censuses from 1790 to 1940. So everybody who was enumerated, some of them twice, of course, some of them not at all. And that is to say, I said this was sort of an evolving data series. There's a missing county in I think 1900. For a while, the whole state of South Dakota was missing from one census. That may mean more to us in Minnesota than it does to people out here. But it's just to say that the data is going to change a little over the next few years because we've gotten in a fairly raw state from Ancestry. So Rui is here, so thank you guys for donating this. And so as we sort of make improvements, things will change. But what is available, and what is available here at Berkeley, is all of these records from all of the censuses with all of the names. Not all of the variables. That will come. That will be coming over the next few years. And in a few slides, I'll give you the schedule for when the enhanced and cleaned versions of particular years will be available. But there is raw data. So if you're a game to try coding stuff yourself at a fairly broad level. Don't mind getting your hands dirty on that, then you can do a lot. And particularly if you wanted to drill down to small groups, then you can, I think, feasibly think about cleaning up the data yourself ahead of our schedule. And I know a lot of people are doing that. But we are going to clean the data so that you don't have to deal with spelling mistakes and all the variations on the way you can spell Philadelphia as a place of birth and all the other things that people misspell and mistranscribe. So it's a huge amount of data, and I want to sort of set this in context of where we are and where we've been in US social science research and then internationally. We started in the 1960s with the US Census Bureau released the first public use microsample of the census. It was a 1 in 1,000 sample of the 1960 census, and in the words of one person after that, after people had used that for a while, a lot of analyses vanished into a welter of empty cells. There just weren't some people with the combination of characteristics you wanted to analyze, and that made things fairly challenging. After 1970, the US Census Bureau released a 1 in 100 sample for 1970, and then also a 1 in 100 sample for 1960, and that set the trend for what they would do in the future. Since 1980, they've been doing 5% samples of the census, and so from 1980 to the present, we have at least 6% of the population, the long-form data, available in the IPMs. In the 1970s as well, as material in the US after 72 years became available, people started developing samples of historical censuses. So 1900 and 1910, samples of those were developed. Hal Winsper at the University of Wisconsin did 1% samples of the 1940 and 1950 census, basically under contract from the Census Bureau to sort of make an official product for those slightly earlier censuses from the Census Bureau's perspective. Where Minnesota sort of became involved was in the 1980s, and there'd been these historical samples of 1900, 1910, and Steve Ruggles and Russ Menard thought, well, it'd be a great idea to do 1880. It's the first census that asks people's household relationships, and so you can do a lot of demographic analyses once you definitively know who's related to who in the household. And so that was the first one that Minnesota released. And that was sort of fortuitous for when we later became involved in doing complete count data. 1880 was great, apparently, but they discovered it had different codes from some of the later ones. So in the 1990s, you had this 1880 sample, you had this 1900, 1910, 1940, and then all the way to the present. And the only two that had the same set of codes for common variables were 1940 and 1950. Everything else was very inconsistent, and so that's what led to IPIMS to put the same codes on the same variables across time. A fairly simple idea that would make analysis easier, but at the time people thought it was kind of funny. Later in the 90s, we became involved. The Church of Jesus Christ of Latter-day Saints came to us about the 1880 census, and they had been typing it in since 1982. They started this project, the LDS Church, to transcribe the entire U.S. census of 1880. I was alive for all of the period that this was being done, and I'm sure you guys were as well. Computing technology apparently changed a lot between 1982 and 1998. And so they had some issues after all these years of releasing the final product and making sure things were not duplicated. They had they had problems with the rows, but they also had problems with the columns. There was a lot of material in their database where there was an occupation where there should be a birthplace, things like that. There was a lot of problems. So they came to us and they said, look, if you help us clean this up, then you can release it for social science research. And at Minnesota, we thought this would be great, the whole population. And then it turned out they'd also been doing the 1881 British and Canadian censuses, same kind of thing. They started a little later on those. I think learned some lessons and gotten a little quicker. But sort of keep this in mind in terms of the development of this. 17 years basically to do 1880, and then we released that a version of that in 1999. Another basically 17 years later, we now have all of the censuses. So there's your Moore's law for historical data. Seven times as much, or 7 times, about 15 times as much data in the same time as that first census. So they thought we did a nice job, and they gave us a plaque. It was kind of appropriate. They had a spelling mistake on the first version of the plaque that they sent us. We asked for them to correct that since it was going up in the living room wall at the Minnesota Population Center. Here's another kind of indicator of the time when the time that this was released, 2002. They released it on CD-ROM, 55 CD-ROMs. So that's who has CD-ROMs anymore? Certainly not for data. So after they'd done this, Family Search decided that they would go and do the rest of the U.S. censuses, and they did this in a crowdsourcing way. The previous work had been crowdsourced. It was done at LDS family history centers around the world. They took advantage of the internet, and so you could download a little program that ran on your computer and sent the results back to Family Search, and everything was double entered in this process. And that took them 5 years. So there again, there's just sort of another variant on Moore's law for historical census data. 17 years to enter 1880, and then just 5 years to enter the sort of 700 million additional records, just under 700 million additional records from the remaining censuses up to 1930. So that's sort of one component of what is now available. The other component is 1940. 72-year rule, so this was released to the public, the images, in 2012 on April the 1st. And MPC learned that Ancestry was, of course, planning to digitize this, and we made an agreement with them that they would type in the additional interesting variables beyond the sort of identifying ones that genealogists are interested in, and they do that basically at the same time, so that we wouldn't have to sort of go back and find the same rows and then add the variables. That's a process which leads to a little more error. And so this was 134 million people, 7.8 billion keystrokes. It was a very large project, and it was the data was entered in just under a year, if I remember rightly. And so since 1940, since 2013, we've had a version of 1940 available. 1940 is a very rich census conducted at the end of the Great Depression, on the eve of World War II, and after the introduction of New Deal social programs. And so there's a lot of questions which reflect that context that the government was interested in finding out. Had you enrolled for Social Security? Things like that. It's also the first census, and this kind of complicates some analyses, to introduce a sample line so that not everybody is asked every question. And in this case, it's a 5% sample that is asked those additional questions. Most of these are in the data set. One of the sort of very valuable things that is in 1940 is they ask a question about where you were living 5 years ago. It's very detailed. There's a lot of residential stability, people living in the same house as these people are. But if you had moved, you were asked the incorporated place that you had moved from. There's some issues with cleaning up this data. In the US Census, you're asked, for example, for your state of birth. People can remember a state pretty well. They don't tend to give answers that don't correspond with the administrative geography. When you ask people 5 years later, where were you living 5 years ago, they give answers that don't correspond with official place names. And so cleaning that up and putting it, giving it a code that corresponds to a known place that's uniquely identified is taking a little bit of time. But that's one of the challenges with this 1940 data, is this sort of the scale and some of the complexity of the questions. It's a census which also includes the first national collection of data on education and educational attainment. Previously, people have been asked about literacy. You're still asked about school attendance, but this for the first time collected, and for the entire population, data on educational attainment. So a very rich source of data for understanding the US in 1940. And then it asks questions about occupation and industry. We have not, this was a sort of concession to how much information we could pay for. Industry, there are codes on the page. And so what we've got in terms of industry is the original codes that were written down on the page. That reflected the processing that the Census Bureau did as they were sort of compiling the statistics at the time. They wrote a code on the manuscripts, and we can see that, and that's what we've got for industry. For occupation, we have the entire occupational string, and so we're able to put a little more detail into how we've described occupations. For industry, it's a little more coarse what's there, but you can identify major and important industries. It's just that with occupation, we have a lot more detail. So the terms under which this is available, so what you have here at Berkeley is this restricted data, and that has the alphabetic strings. So if you want to look at the precise occupation that is reported, you can do that with the version that's available here at Berkeley. The other, if you're from another institution, and I know there's economists in the room, the NBER has a copy of all of this data, 1940 all the way back to 1790, and so it's possible to access it via NBER as well. If you're from another institution, and there's, I heard some other fine universities being mentioned as we went around the room, you can get data without names, non-nominal data, without a problem. And I'll talk about sort of the release schedule for that. We've got 1940 is in the IPMs. You can go and make an extract of the whole 1940 census. You won't get any names, you'll just get codes, but that's there. There is a process to get a copy of the restricted data to your institution.
Let me just say that we're also happy to serve as a connection for you to data
Yes.
to Berkeley. You'll just have to follow,
Berkeley rules.
papers.
There you go. I did not want to make the promise that Josh would give you access to his computer, but if he's willing to do that, and he is, I think, the responsible person, then that's great. So yeah, there's two sort of ways in which this is available. One is with sort of just codes, but if you're looking to do linking, you're needing the names, and that is available under a more restricted process, which is not too onerous. Basically, you have to demonstrate if you're thinking about, do I want to bring this to Stanford, to Davis? Do I have a secure computing environment that I can store this in, and am I happy to answer questions from my colleagues about how to get access to the data? So if you've got a competent IT staff, it shouldn't be too much work. Skipping over that. So I can't comment on your quality of your IT staff. So as I say, this came in a fairly raw format a couple of years ago, and so we are in the process over the next 3 or 4 years of making improvements to the data. The most important ones is that additional variables will be added to the 1930 through 1860 censuses. So at the moment we've got basically those genealogical variables, name, birthplace, age, parental birthplaces, and those are great and very, very useful, but you can't do a lot of analyses with them. Over time, Ancestry is adding the sort of socioeconomic variables to the data for us, and we're sort of taking that in as they complete each census, and they're working backwards, and so are we. So we've got 1930. We expect to release a sort of a cleaned version of 1930 early next year. Then we'll do 1920. We just got an updated version of 1910, which has all the additional variables. 1910 has some great economic variables, including questions about unemployment. So but for 1900 through 1860, apart from 1880, which we've got already available in the North Atlantic Population Project, that's online, so you can get it. For 1860 through 1900, at the moment, you really can't do a lot with it beyond finding somebody by name. Obviously, you can get their sex and age, and there's some demographic fertility stuff you can do with it, but those questions about literacy and school attendance and occupation, they're not there for 1860 through 1900. So we're going to be coding this, 1920 and 1910, for example, where we've got the data for occupation and all the sort of interesting questions. Now it needs to be coded. We'll also be doing data cleaning. That was one of the sort of data cleaning and missing data allocation has been something sort of central to what IPMS has done with the historical census samples. We did a lot of hand lookup, so if we saw a 9-year-old coal miner, we'd have a graduate student go and look that up on the microfilm or online on Ancestry and see, is that really a 9-year-old coal miner? Often it was. We can't do that on this scale. So what we're going to be doing is basically taking our database of fixes we've made in the samples and using that as a sort of hot decking sort of basis for fixing things in the complete count samples. So if we see a similar error or in the complete count data, and we've made a similar fix in the samples, then we'll kind of donate that fix into the complete count data. That'll be flagged so that you can throw out the cases which have allocated values. But there's a lot of missing data in the census. It's particularly high non-response rates on particular questions. So parental birthplace, for example, has a pretty high non-response rate compared to other variables. So you should always be aware of that, with the IPMs. We'll also be doing IPMs constructed variables. These are your pointers, like where in the household is your mother, is your father, how many children are living in the household, what's the oldest and youngest child that you have of your own in the household. So all the sort of standard IPMs features will be added to these data sets, but we'll be doing it in a slightly different way. As part of these additional variables that are being added, they include things about the house. These are fairly basic. One of the things if you've looked at the census form, you'll notice about these is these are often just 1 or 2 characters. They're fairly cheap to enter. Home ownership, for example, is really very easy to enter because there's a very small range of things that people report, so it's very quick. And easy to recognize that's an O, that's an R, that's mortgaged, and type them in. Value of home, you're just seeing whole numbers basically, 7,000, etc. So these are fairly quick to enter, but they'll be added to the censuses. We'll be adding more demographic variables beyond the basic age, sex, race that are there at present. Again, these are fairly simple to enter. So we haven't, for the 1930 and earlier censuses, added everything. I mentioned that with 1940 we have one substantial omission, and that's industry, the industry string. From 1860 to 1930 we have more omissions. We've tried to minimize them. And the ones that we've captured are ones where we can get a lot of analytical value out of a small number of keystrokes. Basically, we're trying to maximize analysis per keystroke entered. And things like this, I think you can see why there's a small range of values. These are easy to enter, but these you can do a lot with data on age at first marriage, how many children you've had. Josh was just asking me about, can you identify twins in this data? When you have birth month, yes, you can identify twins as children when they're living together. And a colleague and I have got an application which we're writing for NIH to trace the twins forward. Disability. This data sounds enticing. It's really not great, but go ahead and look at it, and maybe you'll prove everyone wrong. The people who've looked at it with the samples have not found much there to analyze. I think a big one, wealth, which we have in the samples from 1850 through 1870. That'll be available for all of 1850, 1860, and 1870. So a lot more observations on wealth. I mentioned the sort of quote about the 1960 small sample, the welter of empty cells. One of the problems that people have found with analyzing the wealth data out of the existing sample data is really that there's not a lot of cases in particular areas, because a lot of people are not reporting wealth. It tends to be men. We'll now have a lot more observations on wealth, and so be able to construct, particularly for particular areas, a measure of how well off the place was. So now that I've sort of told you, look, we've got great data available now if you want to get your hands dirty and code some of it yourself. When is stuff coming in a cleaner format? So at the moment, we have publicly available 1880 and 1940. 1880 you can get in two ways. One version without names on the IPMS website, or the North Atlantic Population Project has a version with names if you want to find individual people. 1940, it's available now. 1790 to 1840 and 1850, these will be coming along very soon. early, I think we're realistically going to say early 2016 at this point. The next ones to come along, 1930, this will be coded, and then 1920. These are very rich censuses, and the administration of those censuses was better than some of the earlier ones. So these, I think, have a lot of research potential. And one of the things I've sort of noticed with the research that people are doing at MBR and various other places is a lot of people are linking sort of external sources to the census. 1920 and 1930 are particularly good for that because they've got a lot of rich detail in the census, and then you can add. There's a lot of other sources available around these times to link to. And then, as I mentioned, we've got a very raw version of 1910 with additional variables. You're probably looking sort of 2017, 2018 for these 19th century censuses. The restricted data, so if you want the names, they're available now or in some format. We'll be getting in touch with the sort of institutions that have a copy of the data to tell you about when you can get 1910. It's a good census as well. So yeah, these are available fairly well now with additional variables. But there's sort of this big gap in the middle. That's what you've got to wait a little more for.
One more time, what the difference is between the bold and the not bold?
Oh, bold is bold. We've got the additional variables. Yeah, where and so I didn't update for 1910, but literally we just got an email. Here's the data. Here's the FTP site. So I think, given our 25 minutes, I will sort of stop there. This is what's available. As I say, we have plans to link this, the 19th century data, and then we'll be submitting an application to do a sort of a public use version, linked versions for the 20th century data. So, questions?
Thank you.
Are data available for the enumerator? Is it possible to know who enumerated, like a code for an enumerator?
Can you repeat the question?
Oh, who enumerated them? That varies census by census. As you know, it's sort of written on the sheet. What is definitely available is the enumeration district, and basically by sort of controlling for the enumeration district, you can, to some extent control for enumerator variability. I don't think we've ever tried to, because obviously some enumerators did multiple districts. I think we sort of know that. We've never tried to say, oh, this looks like the same name, and really do data linkage on the enumerators' names. Yeah, but definitely enumeration district.
How about the slave censuses?
Yeah, that's a really great question. So
Repeat the question.
Oh, sorry. The slave censuses. So there were slave censuses in 1850 and 1860. The 1850 public and restricted versions will both contain the slave census. 1860, we've taken delivery of it. I don't think there's additional variables, and so for that, and so we can, we can sort of make available a copy of the data. One of the challenges with the slave census, and this sort of took a lot of our time with 1850, is that it's done on separate manuscripts, but there's meant to be a connection back to the population census, and that's where a lot of the analytical power comes from, is there's a slaveholder's name. But it's just a name, and I think for 1850 we've sort of got into the range of, we've been able to link about 90% of the holdings and about 90% of the slaves to an owner. But there's a lot of, there's two types of problems. One is that you have people who, the owner was not resident near the slaves. So you'll get people who are, you can go and Google some of these folks, and we did, on Wikipedia. It's like, oh, that turns out to be a fairly wealthy northerner who's owning slaves. And it's really, we did not have the time nor the money from NIH to make those links. So we've kind of left them, in the place the slaves were found, but we haven't made a link to the population schedule. Another challenge has been that there's, this was the nature of slavery, corporations and corporate entities that owned a lot of slaves. The city of Charleston, lots of southern cities own slaves. It's really hard to link the city of Charleston to the pop. There's no entry for the city of Charleston in the pop census, but they owned a lot of slaves. So there's some challenges there. The mortality censuses are actually going to be included in the sort of 19th century ones as well. Similar challenges with those is that there's not as exact a correspondence as we'd hope, but 90%. It's pretty good. So yeah, we really hope people will make use of that.
But 1860, is it coming or like not?
We've got the data. I'm just trying to sort of give you a realistic sense of what would be done. I think 1850 would be probably a better one to start with, just because there's really not much you can do without having it linked to the population schedules and being able to say who's the slave owner or the holder. So, yeah.
Do we have veteran status in your data?
Yes, we do. That's a great question. So veteran status is asked 1930, 1940. It's never really been analysed. There's a history to that. 1930 was never meant to be analysed. It was done or collected for the Veterans Bureau. And then 1940, they collected the question, and then of course there were more pressing issues than finding out about the World War I veterans by the time they got to analysing the 1940 census. So it's there. It's I've been doing some work with about the World War I veterans. An historical society, the Minnesota Historical Society, and the Oakland Museum of California, and a couple of other major museums. They're doing they're planning a big World War I exhibit, and so they sort of contracted me to do a little analysis of what's in 1930 and 1940 about World War I veterans. So what I can tell you is. It's pretty clean. I mean, there's a lot of different ways to write WW1, it turns out, but you can pretty quickly identify, the sort of 3 million odd veterans. 1940, there's a lot of under-enumeration, and that was sort of known at the time. So there's a bit of a challenge, but it's definitely there. The previous census, which asked a lot about veterans, was 1890, about Civil War veterans. You'll notice that's not there. I think, as many of you know, the 1890 census manuscripts were destroyed in a fire, so they're never coming. But yeah, there's good news for World War I especially.
Do these include the census of all the colonies and territories and possessions for all the decades in which they were taken?
Can you repeat the question again?
Yeah, sorry, the territories. Yes, so we've got Alaska, Hawaii, Samoa, I'm just trying to, Puerto Rico is in there as well. As you can tell, I didn't grow up around here. So I've actually, I'm from New Zealand originally, and so I was a little interested in the Samoan census, and it's pretty small, so you can load it onto your laptop and fiddle around with it pretty easily, unlike a lot of if you're doing the whole of the United States. So yeah, no, the data's there. Because we've never done territories before, we had not made sort of final plans to, how we're going to include them. But if you're interested in the territories, get in touch, because yeah, sort of untapped resource.
There's also an armed forces sample that is Emotions, right?
Yeah, that's exactly right. Yeah, there's people who are stationed abroad. Yeah, so there's an Army, Navy, Marine. Yeah, eventually maybe there was Air Force. Yeah, so there's a file for that in a lot of these as well.
I'm sorry, just a quick follow-up. So I thought I was going nuts, but so Dora Costa's work, I think, is Union Army veterans in the
Yes.
census. Do you guys envisage any linkages to that work?
So the question there about linking the Union Army people to the census. So one of the grant that we've got to do data linkage from 1860 to 1900 is being led by Dave Hacker, who's a demographic historian at Minnesota. He's published about sort of Civil War death toll. So the challenge there is really linking the other sources which say this guy was served in the Union Army to the census on a mass scale, and we've been thinking about ways to do that. That's really the challenge. Is it's not enumerate. Well, I'll say that there are in 1920 this guy 1930 there's guys who say I was a Union Army veteran, but they're very, very few. So it's a challenge of bringing in other data sources to do that.
So I was wondering if you could just describe a little bit what your personal position in this project is, and then how you see the project evolving between the various data users and Minnesota in the years ahead. Right now it's from Minnesota out. Is there plans to distribute the work and share it in other ways?
That's a great question. So my position, I promoted to with the data linkage. My role is going to be coordinating the data linkage, spending a lot of time on that. In terms of your other question,
Maybe specific with data linkage. For example, we have people here doing data linkage, you're doing data linkage. How is the community going to be formed?
so our goal and what we've been sort of funded to do is to do basically a nationally representative sample from complete count to complete count. The way that we envisage doing that is starting 1900 and working backwards, because we know that if you're older than 20 in 1900, we should be able to find you in 1880, conditional on having migrated to the United States before that. So that's our goal, is to do a sort of a nationally representative sample. I can talk a little bit. How are we going to do that? We've got sort of our thoughts about this to proceed in two ways. One is to do what we've done with the existing sample data, is to do a fairly restrictive linkage process where we really are not trying to maximize linkage rates, but to minimize false positives, and to get a fairly representative sample. We would sort of complement that, I think, with a sort of more maximalist approach, similar to what the Census Bureau does for some things, where they look for you first in a household context, and in the same place that you might have been in a previous enumeration. And by doing that, you're able to make a lot of linkages, people who are in sort of stable residential and household context, and then you're left with a much smaller number of, they're not necessarily single in a marital status sense, but people who are basically, they're the only similar person in their household in the different enumerations. Those are the people that are hardest to link, but once you've sort of got the pool of potential matches down to, you've eliminated all the people who can be, who are married or staying with their parents, then you're not having to make as many comparisons. And we hope that we can, using that process, get up to sort of 80 to 85% linkage rates, which, given under enumeration on the order of sort of 5 to 7%, you're probably not going to get above 80, 85 linkage rates, across a 10-year span. So that's our sort of our broad vision there, and we're collaborating with Martha Bailey at Michigan, who's doing some work with civil registration, birth and death registration sources. This is a sort of we're planning to put in a PO1 to do some of these linkages next year, and the sort of the scope of that. How much is at Minnesota? How much is elsewhere? I think we're recognizing we probably need to we're going to broaden this. So that's keen to hear your interest in participating as we go forward.
Thank you very much for having me. I will say, as an economist, I'll feel really awkward if nobody says anything for the first 25 minutes. So please feel totally free to yell and complain and ask questions that are either clarifying or hobbling to my argument. That's fine. So I'm going to talk today about a machine learning approach to automated census record linking. And what the broad outline is that we know that individuals, like if you hired a research assistant to go on to Ancestry or Family Search, they could make individual matches pretty well by hand. The goal here is to think about, is there a way that we can essentially teach the computer, teach an algorithm to replicate and to act like a really well-trained research assistant, and do that at scale, and so faster, cheaper, and possibly even better than the gold standard of a well-trained researcher. And so I'm going to talk about that a bit today. So we have all become, or are all becoming, sort of big data genealogists. We're not so interested in tracking one person so much as we want to make these huge links. And this is both with the complete count data that Yvonne talked about from Ancestry, and it's available from Minnesota, and that's going to be sort of on the servers here at Berkeley. And there's also, as Yvonne mentioned, there's the NAPP, which has other countries. There's other efforts to create these other sort of full complete count census data sets. The really cool question is what kind of questions we can ask and answer. And I'm not going to talk about that at all today. You guys all have your ideas of things you want to research. What I want to focus on instead is, well, how do we build a linked data sets to answer these questions? You can do a lot with just 100% sample, say of 1940. You could calculate something that's really local about town level information. But where the excitement of these complete count data really scales up is when we can link it to other data sources, either across censuses or bringing other data into the census. And so how do we create these linked data sets that are linked at the individual level, linking one person from one source into the census? And so it's probably good to define kind of what we're after. I think that a record linking procedure should be efficient, which is to say, if we look for 100 guys, let's try and find as many as we can. It should also be accurate. Of the matches we make, most, if not all, should be the correct match. And it certainly should be unbiased, and I mean that in the sense that we're going to create a sample at the end of the day, and we're going to take our econometric toolbox or our social science toolbox to that and run some regressions or do some analysis, and we don't want whatever we learn at the end of the day to be a function of our record linking procedure. But it would also be great, because we're doing this in the real world, not the ideal world, if whatever we're doing was fast and relatively cheap, and if it were consistent, and if it were replicable, and if it were flexible. And I'll describe each of these, sort of how I'm conceptualizing each of these terms as I go through the talk. So efficiency first. You can think of these like type 1 errors, or a true positive rate. This is basically, again, if I'm looking for a group of people, what share of them do I find? In theory, most people, if I'm looking from the 1930 census into 1940, and I grab 100 people from 1930, most of them are still in 1940. How well does my record linking process do at finding them in 1940? And this is, efficiency sort of can be important and less important in different contexts. So if we're doing, like Yvonne is talking about, linking one complete count census to another, maybe efficiency is not the most important metric, because we're going to have a really big sample no matter what we do, even if we have a pretty crappy match rate. But if you start with a really small sample, so this is I'll discuss this data set in more detail as I go through the talk. I have this sample linked from the Iowa 1915 state census, particularly the children of Iowa 1915, into 1940. If I only have a 10% match rate, if I'm not very efficient in making those matches, I'm going to have a sample that's much too small to do anything with downstream. And so I want to create a linking procedure that does a really good job of getting a lot of these matches. That said, you could get a 100% match rate if you just pick people randomly. And so efficiency in a large way is sort of dueling with accuracy. And this is how many of these records are linked correctly. These are the type 2 errors. These are, I'm going to call this guy a match with this other person, and what share of those are true matches and what share of those are not. And then finally, the unbiased, I discussed this previously. So we don't want sample bias. We don't want our final result to be just totally an artifact of how we did the matching. And so this is something I think maybe we'll discuss later in the roundtable. This is something that I don't think we formalized well, sort of the test. What's a test for, do we have an unbiased record linking procedure? I have a few papers where I use record linking. I sort of wave my hands and try to show you why what I'm doing is unbiased and cool. But I think this is somewhere where we might want to try to push on and think, are there ways to formalize that? Andy?
Is this only a feature of the procedure, or is it also a feature of the underlying data, where some people's names might by nature be easier to match?
So I think the unbiasedness in the outcome, it depends on the procedure you use, but a lot of sort of that unbiasedness might come from the underlying data. So if we have data, if certain types of names are hard to enumerate because they have lots of Z's, and Z's in cursive are a nightmare, but people that have Z's are also special, and so we sort of miss them or undercount them, then it is from the raw data, but that might flow through our linking procedure into the outcome. I think the unbiasedness could sneak in lots of different ways. Marcy?
You can defer this till later, but who are the true positives?
That's a great question.
Repeat the-
Sorry, so who are the true positives? So there is no true positive in the sense that we don't have social security numbers, we don't have unique identifiers. That's sort of where we are working with historical data. I'm going to consider in this, the true positives are a really well-trained researcher, whether it's someone that Yvonne has taught at Minnesota to do these links individually, or whether it's me being really careful on Ancestry.com. The links that researcher who's well-trained would make, I'm going to call those the true positives. But that's absolutely right, and that's sort of where we're, flying without a net, in that we don't always have a ground truth for the exact matches.
But could it be possible to get a social security matched from, if you worked with the Fed person?
So we're not going to see social security numbers in the census ever, I don't think. I mean, yeah, you may have more thought on that.
So with the 1940 census at the Census Bureau, what they've been doing is assigning the protected identification keys, which basically gives people that. But that's for 1940. I mean, I think, your question, the more challenging thing is going back earlier. And so I think,
We're sort of, we purely have what we have in the
But this
census.
isn't about linkage. I mean, it's
Yeah.
a procedure, right?
Yeah.
So if it works
Oh, I see what you're
procedurally
saying.
in a different, like Jonathan is working with social security numbers to track something, bankruptcies,
So you could absolutely test anything I'm going to talk about in data where you did have a ground truth. You could ask Raj really nicely for the tax data, and you could do that. But to the extent that the problems we're going to encounter in historical data are different than the ones we might encounter in modern data, because this is all, as we saw in the pictures in the previous talk, this is handwritten enumeration. That's the historical data has so many potential sources of error, even just on somebody's name, that that might, if the procedure does really well, where we do know the ground truth, that might give you some confidence, but there's sort of an upper bound to that because the context is quite different. That's a great point, though. Okay, cool. So just a couple examples of bias you might run into. So in the olden days, when we did historical linking and we didn't have big computers, we sort of looked for people where they used to be. And so this is from my Iowa Sun sample linked from 1915 to 1940. It turns out that sons who don't leave Iowa all earn $35 a week. The sons who do leave, there's still a little bit of a bump around $28, $29, $30, but the distributions look very different. And this is just to say, if we create sort of restrictions on how we're doing this matching, like for example, saying, I'm going to assume someone doesn't leave a state, we're going to bias our data, and that I don't think that's going to surprise anybody. This one was actually a little bit more surprising when I found it the first time. This is exact matching. So this is from another sample I have. From guys that were living in Cambridge in 1910. I linked them back to 1900 and ahead to 20 and 30. And you can do the full sample with sort of my procedure. You can also just take the guys who are exact, which is to say the same exact first name, the same exact last name, the same state of birth, and the same year of birth, so ignoring all the messiness of historical data, and you find a different sample. you find these guys are more likely to be married. They're different on other dimensions as well. They're also, I think, less likely to leave the city. They travel farther if they do move. So that is to say that sort of doing a very strict match procedure, and this is true of exact matching and of other methods as well, you're going to develop a different sample. You might be worried that if I want to tell you about divorce rates or marriage rates among this population, an exact match sample is going to look very different than something else. Okay, so as I said before, like the gold standard hypothetical is this researcher who can match by hand. This is going to be really accurate. It's going to give it enough time. It might even be efficient. It might be unbiased, but it's going to take a very long time. And presumably you're going to hire multiple research assistants. They're all going to make slightly different choices. So your sample might have some random noise depending on who's working. People might get better or worse at this over time. There's sort of a lot of messy features that we don't want to have to deal with. It's also not very replicable, as I said, because it's a sort of a human doing it over time. We'd also like a procedure that's really flexible, and you can think about this flexibility in lots of different ways. The main goal of this discussion maybe is to think about linking one census to another, but we've got lots of other historical data that Yvonne mentioned. You can link state censuses into federal censuses. You could link other sources. I have a sample from the Bureau of Labor Statistics, a cost of living survey 1918-1919 that I link into censuses. So there's lots of historical data out there that can be made much richer, and the census data itself can be made much richer by making these links. And so we'd like to think about a procedure that works not just with two census data sets, but maybe bringing in other data. And then Ron and Katherine and Linkage have this work where they actually link other countries into the US Census. So we'd like to think about a matching procedure that is flexible, so they can hopefully sort of address all these different points. Okay, summarize. Great. All my method is going to do is sort of use a machine learning trick to replicate how this well-trained and then ultimately hyper-consistent research assistant would have created a match sample across censuses. And to make things really concrete, I'll talk about the data that I work with the most, which is this link of the Iowa 1915 into the federal 1940. And I'll call data set the first one X1 and the second X2. 4 steps, actually 3 steps. You find a group of possible matches. So for each son in 1915, that's an X1, I find all the people he could be in 1940 in X2. And then for some small subset, you get a researcher, or you do it yourself because you run out of money to pay Harvard undergrads, and you manually identify the guys who you think are a match. They take 2 names. Is this the same person? And this is relative both to the individual match, but also the other people that you sort of pull up as potential matches for this one son. And then you train the algorithm to approximate and to understand all the implicit choices that a researcher made in making these links. And the 4th step is remarking on how easy that was. But obviously I'll go into a lot more detail in 1, 2, and 3. Yeah.
This maybe goes back to the earlier question.
Yeah.
Why do we think the person is a good matcher as opposed to inventing our own automatic algorithm that's going to be better than a person?
That's a fair point. I
think, for example, the talk that we will do the more automated one, and it has key disadvantages if it relies more on distributional assumption, and James' method does not rely on
That's
that.
right. Yeah, there's definitely there's more assumptions baked in. There's also sort of, I think maybe the intellectual genealogy of this is that when you think about how do I create matches across space, the first thing you do is, well, people have this skill of people are good machines for making these links. Like once you have the Ancestry interface, you can go in and look for people. And it's also convincing skeptical economic historians and others that what you're doing is okay. Sometimes it tends to be good to be like, oh, I did whatever you would do if you were at home trying to find your grandparents, but on a big scale. But no, I agree. There's different ways.
These are people visually looking at the census.
This is looking at the not the form itself, but the output raw data. So I'll show you pictures of exactly what it looks like. Yeah, the transcribed version. That's right. But no, I agree. If we had a gold standard, you'd want to train an algorithm to do that. We don't have a gold standard, so let's sort of think that people are pretty good at this. That's a great question. Okay, so that first step is to extract the guys who could be a person. So I'm looking for myself or for I'm not in any of these historical censuses, but I'm looking for somebody's grandfather, and you find there's a big group of people who could be that person. In the maximalist sense, it could be anybody. You're looking for a son from 1915, anybody in 1940 could be that son. We want to restrict that space a little bit because we have a limited amount of computing power. And so the question really is then how strict or lenient to be on this first group of people that we're going to look through. And what I'm going to draw is some work from the IPMS folks, and I'm going to limit this set of matches to first, I'm going to require you to have the same state of birth in both data sets. And that's a limiting assumption, but sort of it's not really tractable if I don't make that claim to begin with. And then I'll consider differences in ages. And this is from the IPMS sample. They already have these nice samples linked from 1880 to other censuses, and it tends to be the matches that they made. This is both a function of the rule they used, but also the output data, is that in these historical data sets, people tend to be plus or minus 2 years away. So like your year of birth is given as 1875, and I'm going to make those matches plus or minus 2.
Is this from the training data set that they use, or from the output?
This is from the output. I don't think the training data set is. One could do the same thing, and I suspect you'd end up at pretty much the same place. And these are, I want to say, this whole slide. This is how I've been doing it. Sort of the nice piece that's flexibility. If you knew you were working with a data set where there was a lot of age heaping or a lot of misreporting of ages, you could say, I want to be way more lenient. I don't want to do plus or minus 2 years. I'm going to do plus or minus 10 years or 5 years. And this same procedure could follow through. You'd just end up with a bigger set. Or if you knew, if we had some other data that had months and days of birth, you could be even much more exact and much more restrictive. So you should keep that in mind. These are sort of rules of thumb that I'm going to use as sort of a default project for matching into the census, but you can imagine all of these are sort of, the knobs are twistable. And I'm going to use another trick to cut the sample space down. So now I'm looking for a guy from 1915 Iowa in the 1940 census. I've now limited it to anyone born in the same state, born plus or minus 2 years. And then I'm going to cut the data again using the Jarl-Winkler string distance of names. And I'm only going to pick people who have relatively similar names. And just, if you guys haven't seen Jarl-Winkler before, just some trivial examples using my own name to think about how these differences look. But what it turns out in the IPMS data is that almost 95% of the matches have both a first name and a last name within 0.2 of this Jarl-Winkler string distance. And again, this is something where if you know your data is messier or more precise, you could move the red lines one way or the other. This is sort of, again, just this rule of thumb. But I'm gonna restrict these matches to be somebody, again, who has the same state of birth, year of birth plus or minus 2, and then the string distance name, both on first and last name, but within 0.2.
The x-axis is blocked over as first name?
Oh, yeah, that's terrible. I can't make that go away. Yeah, the x-axis is first name, the y is last name.
What do you do with the next?
You've got to the Achilles heel of this whole thing. This procedure is only ever going to work for matching men. I mean, yeah. We're living in such a world where if some set of women are going to change their name when they get married, and that's not a random sample, the historical linkage, you're going to need some data beyond the census, I think, to match women. So sorry, I should have said that way earlier.
I mean, it works for women if you have their maiden name.
Right.
But that's
Yes.
the
If you have some other data set where you know their maiden name, so what Martha Bailey's doing in Michigan, she has marriage records and birth records and kids' birth records that sometimes will say a maiden name. So if you can bring some other data to bear, then you're okay. But yeah, this is going to be a very much a father
Conceptually,
son.
can't you do it without the last name? It just is going to have to be results? Or it won't even work?
It won't. Yes, you could do it. You will make no. It'll be.
You'll be identifying someone who's incredibly unique on their combination of their state and their age and their birth year.
And the first
so
name.
they have a really unusual first name. In Britain, you can actually because people have parish of birth, you can actually identify
You can do a little
women
better job.
because they're in some parishes. There's only one girl in a particular year, or in a particular or in
With
5
a
years
given
with that
name.
name.
Yeah, but you will end up with the same,
Yeah.
problem of the John Smith.
Yeah.
That you will
Oh,
end
yeah.
up having too many of them to be able to determine which one
That's
is the right one.
That's absolutely right. Okay. So you wanted to see sort of what the data looks like. This is sort of how someone's going to train this. Is you can basically have a console open. Samuel Cohen is going to be really hard to match, and this is probably born in either New York or Massachusetts. There are just way too many Samuel Cohens that match exactly. We're never going to be able to figure out which one is exactly him. And so that we just mark as not matched because we can't be confident about who's it going to be. This guy is Harry Farrar. We can see there's only one person in the 1940 data set, or maybe this is a different year. There's only one person in the outcome data set that has a name even within our bands for Harry Farrar. And so we're going to very confidently mark this as a match. There's others that are sort of somewhere in the middle. So William Barry here, you can see the first one. This is to give you a sense of how big this set of possible matches is going to be. There's other guys who sort of match on William, and then the last name's not quite so different, and the year of birth matches. But really, only that first guy, William Barry to William J. Barry, both born in 1875, is going to be the one that we're going to mark as the match. Andy?
This is a tiny question, but
Yeah.
Is there any advantage to doing these distances separately on first and last name and not on just the whole name?
Yes, actually, particularly with the Darrow-Winkler string distance, I didn't go to the details, but it basically it weights the beginning of a string much more heavily, and in fact, sometimes the end of the string levels get to no weight. Especially if you do a last name plus a first name, you're already at like 15 characters. That 15th character is going to be kind of ignored. So I think there's definitely some value. Yeah.
Sorry.
No, please.
So in the manual phase, did you try to use other variables that you won't use later for like other household members? Whether you stay in Iowa, you can then train the computer not to take them into account,
but use them in the master data. I haven't done that. That's an interesting question. I don't know. It should. Yeah, I can't answer immediately whether that's going to give you some bias later. I have to think more about it. But you could imagine using that information. And I'll talk about this later. Like I'm for the purposes of unbiasedness, we don't want to do something where we're only where our ultimate training is based on that. And I'm not even going to use race here because maybe we're worried about race either being misquoted or being changed over time. But yeah, you could imagine using that to create the sort of the trained data. So this is going to extract a lot of possible matches. This is just a histogram of sort of, a lot of these are going to be closer to like Harry Farrar where it's a singleton, and then some sums are going to have lots of possible matches. So we've created this training data, and there's sort of two ways to think about machine learning. One is the supervised world where we have labeled data and we train the computer to figure out what we're doing. The unsupervised, unlabeled data, which we're going to see a method using that in a minute, or an hour. As we've sort of thought, the supervised method with training data requires some fewer assumptions, and then possibly some of the machinery is going to be a little bit more familiar to your reading audience and to other people who might want to implement the same tricks, which is why I'll use this method. So we need training data, and so I've sort of hinted at this a bunch of times. We're going to manually identify whether it's you or whether it's a well-trained researcher or maybe in the long run we'll have some training data that just lives online that people can build algorithms off of that will identify which matches are correct and which are not correct. And so I've implemented this a few different ways in R, and in the very long run I'll hopefully put this up in a user-friendly way that people can do themselves. Right now it's sort of a mess on my computer. But you would sort of face the RA with this picture, and they'd be looking for this guy, Roy Spina, who's born in 1918. I've already sorted this by score. Probably you don't want to do that because that might bias your researcher towards picking one or the other. And then you'd look through the possible candidates for who might be Roy Spina in 1940. The first one is sort of the obvious match. It's off by a year of birth, by one, but the name matches exactly, and especially relative to the other choices, Roy Zena, Rocky D. Seminar, Roy Spike. That we're pretty confident that first match is the match. And then so your researcher or you pick the guy that's the right match, or if there's no match, you click the button that says no match here, and this gets recorded, and this is how we create our training data. And so the training data looks something like this. We're going to have all these guys, say from the 1915 Iowa data, matched to somebody in 1940, and then just that really important column that says match, that's whether or not that guy is a match. And what we want to do in step 3 is just to figure out how the human researcher created those matches and non-matches. And so I use a really simple, this is like as easy as I can make it, 2-step process. So the first thing is just to run a probit on whether or not an individual is matched on a bunch of string features. And now the obvious question is, well, what string features are we going to pick? And this is, again, where I'm going to argue the flexibility is key, is that I'm going to show you a list, and you guys may be giving me some good ideas for other things to put in, and we can totally put them in. It's really easy. We just add, we just calculate them and then rerun the regression. But, this is sort of, I think, the big break from the literature in the past on record linking, at least in economic history, is there's sort of been these fixed algorithms for how we do this. We use like a SoundX or a PhoneX or something strict, and we rely on that plus a little bit of year of birth stuff. This is sort of a more agnostic procedure, is that I'm going to use, I'll show you the list first, I'm going to use a bunch of different variables. I'm going to calculate the Jarl-Winkler string distances for first and last names. I'm going to do the year distances. I'm going to ask how many records I matched that you're sort of close to. That sort of gives us a measure of how common your name is. I'm going to do, does your first name match exactly? Does your last name match exactly? Is the first letter of your first name a match? Or the last letter of your first name or last name? Middle initials, sort of, and then of course the SoundX stuff. And we're going to let the training data tell us what weights to put on all of these. And so you might live in a world where the string distances are the only thing that matters and everything else gets a rough 0. But it turns out that each one of these has a little bit of predictive power. And we're going to pull them all in and use them all. And what I don't use, to go back a quick bit, is I'm not going to use race. I'm not going to use anything about geographic location, because I don't want to bias this match on guys who don't move or guys who don't switch races. I'm not going to use marital status. I'm not going to use occupation. These are things that a genealogist might use at the individual level. If I'm just looking for my grandfather and I think I know where he lived and I think I know what his occupation was, I might use those to make those links, but we don't want our procedure to do that because then we're going to bias ourselves towards people who don't change those things. Okay. And I can show you the weights, but they're actually not that interesting, and they're going to vary, presumably, across different procedures. So we run this probit. We get something that's basically a score. That's the probability that an individual guy is matched. But what I haven't mentioned is the probit doesn't really know the structure of our data. That is, if I make that one link, Roy Spina to the other Roy Spina, it doesn't sort of take into account that there were other Roy Spinas who are not the match. And so to take care of that, all I do is I take these scores, and I'm going to declare you finally a match. If you're the best match for a given guy, you're the best candidate to match with Roy Spina. If the score is that probit predicted score is sufficiently big, and that it's sufficiently bigger than the second best match. And these are, again, parameters that we kind of uncover from the data, but at some level, you could imagine this as a rule of thumb. The bigger you make this, the stricter sort of your matching criteria is. And I know, I think that the last time I saw the paper that we're going to see later, there's a big discussion of how to sort of tune these hyperparameters. And so there's this pretty ugly picture of as you make the parameters sort of higher, you decrease your efficiency, but you increase your accuracy. You can imagine, I'm only going to call this a match if you're 10 times better than the second place guy and the score is really, really high. That's going to be an incredibly accurate match, but it's not going to be very efficient because you're going to throw away a lot of people who are just slightly better than the second best score. But at the same time, if you just say, oh, I just need you to be the best score, I don't care how much better you are than the next best possible match, you're going to get perhaps a lot of inaccuracy. So there's some trade-off between accuracy and efficiency. And there's lots of different ways to solve this. The really simple thing that I do is just say, I want to maximize the sum of these two numbers, of the efficiency and the accuracy. And this is kind of an ugly table, but you can sort of tune these hyperparameters to figure out the way to maximize your utility over efficiency and accuracy. And so, to summarize sort of what I just talked about, is that we're going to take we're going to take this group of possible matches for each record in our original data set. We're going to manually identify for some set of matches who we think are the links. We're going to train the algorithm to do it, and then we're going to pick the matches based on these hyperparameters. And so the real question here is, well, how does this model do? And at least relative to the gold standard or the relative to the well-trained researcher, it does really well. So the TPR, this is basically the efficiency. This is what share of the matches that were made by a research assistant are made by the algorithm, is something like 86%. And then the PPV, which is the accuracy, which is to say, of the matches made by the algorithm, what share would have been made by the research assistant, that's something like 87%. Which these can get better. We can improve the algorithm. We can figure out other features to include in the prediction. But they're both relatively high. We're doing a really good job, basically, at zero cost of replicating what the research assistant can do.
So the John Smith is part of the 35,000? Is that?
Yeah, but John Smith is almost certainly part of the 35. That said, John Smith in Iowa is matchable sometimes, because Iowa's probably too big. John Smith in Rhode Island is potentially matchable. John Smith in New York is never going to be matchable. So yeah, he's going to be the not match.
If I get a word on the John Smiths of the world, so none of the papers that you will see today kind of give you any guidance of how to they are not matched. But one of the things that one can do, and there are some, we are starting to think about it in other people, is to use methods like probabilistic matching. So you have one John Smith and you have 10 potential candidates. You don't know which one it is, but it's 1 out of the 10. So you could, in principle, kind of give a weight of 1/10 to each of your observations and use all of them. That introduces some issues in itself, but that's none of
that sounds right, and we're not that sounds right. There's ways to think about those problems. The guys who are too common. I will say that John Smith is a particular problem, but most first names that are not as common as John with the last name as common as Smith will often be matchable. Maybe not from New York, but from smaller states, because once you've narrowed down to a relative, or not even a rare first name, or a not super common first name, even with the last name of Smith, because you've got the year of birth and you've got the state of birth, you can often make those matches. Yeah.
So I understand why you don't want to use geography and all that stuff in your prediction, but do you have a sense of how well your prediction would do compared to a research assistant who, instead of looking at your sorted list, is actually just like going into Ancestry and looking at everything?
I don't know, but I think there's a world in which there's like a crowdsourced truth from like ancestry family trees that might be a cool way to think about how to get some truth. I don't know if you have.
Yeah, I think with the Minnesota population survey, I know where it ended up, but there was an idea of sending a sample of matched records, like 2 records, 1930, 1940, that are attached to the same
tree or
family,
something.
same person on a family tree.
Yeah,
and
that's
I
right.
think someone took over Pérez.
Yeah, Jake was, yeah.
We should-
One of the.
That's like the next frontier is obviously how do you make machine learning algorithms better? You get them better training data. Like the machine can't learn more than we teach it, and so if we have data that's like true from the population, that's definitely a way to make things better.
But that process is taking into account all the things that we didn't take into account.
That's right, exactly, yeah. Or it may even take into account like records that are outside of the 2 censuses. So we may even get a bigger boost than just that.
One more question.
Yeah.
So you said that like all those various things have some predictive value. It's not just the name score.
Yeah.
If you just did it on the name score, I mean, how similar is the sample you're going to get?
What I can tell you, because I'm running out of time, I'm going to go fast.
Sorry.
So none of these are the name score exactly. The SoundX is sort of what was the literature used. It's like 5 years ago, 10 years ago. You can see the increase in the testing data part is the one you want to look at. So, as I said, my method is getting us something like an efficiency of 88% and an accuracy of 85%. SoundX is relatively accurate, although not as accurate as this, because historical data is messy. If you screw up the first letter, SoundX is ruined. And it's obviously much less efficient because you're throwing away a lot of good matches. So I could compare this. There's a boost over using all the other variables relative to just using the name distances, but it's not, I'm going to guess it's not gigantic. I'd say you're probably in like the 75% range on both of these would be my totally made up guess. So what I skipped over is the part where you think I'm really cool because I know I'm fancy and smart because I talked about a bunch of different machine learning things. I didn't just choose, I chose a probit model for 2 reasons. One is I didn't want to have to try to teach someone what like random forests are. in an economic history paper. I thought it was just easier to say I use a probit. This is what I do. But it also turns out the probit methods performs really well on the testing data. So the random forest basically way overfits itself. It's really good at understanding how you made choices in the training data, but it doesn't do as well on the testing data. And so, again, so that's the other reason is that this sort of method sort of holds its own. Okay, so I will not talk about this, although if anyone has questions, I then have slides, but I'll open it up for thoughts and comments. Yeah?
I illustrated your method on a 1915 all the way to 1940 jump. You took a context in which matches of other people within households are probably not important, but the principal use you're making is over a 10-year matching between census times.
Yep.
And over those periods, for many kinds of households, there'll be substantial numbers of overlapping household members. And my belief, watch genealogists work, is that one genealogy is to set up
to match these households together. No, that's absolutely
joint,
true.
And so you have, this has to be one of those, and so you have 4, and somehow there's a match of 4 households to 4 households with some members going and others there, and so that it's a kind of joint optimization. And so I was surprised coming into this that that wasn't the direction you were going, because it's those kinds of problems that a lot of progress in machine learning, those kinds of multiple allocation problems,
that's a great point.
A lot of progress has been directed toward.
Yes.
So could you speak a little about that?
Yeah, so I think you've sort of uncovered where I attacked this problem from was I needed to create a census, a linked sample from 15 to 40. That was the first time I started. I wasn't thinking I didn't think how am I going to do match samples and then apply it to this problem. I was like, I have a particular thing I want to measure. I want to create these father-son linkages from 1915 to 1940, and how can I do that? And so I was always living in a world where I had sons in 1915 who I knew were going to leave the household, and I had to find them in 1940. I think there's definitely scope, whether it's using the full family context to create better training data, or if what you're interested in is these family units that stay together, then using, sort of thinking about how to optimize not just the links, of individuals, but optimize the links of families, which is, in a way, you could apply the same measure. The computation might be a little bit harder, but you could say, I have a set of 4, a mother, a father, and 2 kids, or even just the 2 parents, and you could imagine you're trying to create links across couples from 1930 to 1940. And sort of the same procedure could apply. You could create training data of couples, and then it would just be in your weights, you would have man's first name, woman's first name, man's last name, or they would have the same last name, and it would just be additional sets of features that you would then optimize over, and you would learn, the training data would uncover. I don't know, there's probably economic applications of that where you'd be worried you get a totally biased sample, because then you'd almost wouldn't match, you'd almost by default wouldn't be able to match families that break up. But if the thing you're interested in if that's not a problem for whatever you're doing, then you could absolutely create this joint optimization over whole households. That's right.
So there's a process underneath the errors. There's people typing things in, people reading handwriting.
Yes.
So that's so we can actually have a whole theory of what that process is and what kind of errors are more likely, and we can learn something about that. Mm-hmm. And then there's also the attribution process, where I'm never going to call a Feigenbaum a Teigenbaum, just because that is just bad for my brain or for a human brain. But actually, it could be very likely that an F and a T.
Yeah, no, F and T cursively look exactly.
Are there some lessons maybe that you've got? Can we use this method to get lessons about what kind of mistakes are likely at what stage, whether the human?
That's exactly right. I think you can definitely do more than I currently have done to think about sort of. By using the Jaro-Winkler string distance, I'm sort of agnostic to what kind of errors are the same. As I showed you, the Feigenbaum-Teigenbaum difference is exactly the same Jaro-Winkler difference as any other first letter on my name. But when you write, the 1920 enumeration of Feigenbaum, F's and T's are much more likely to be mistaken for each other than an F for an S, or an F for an A or a B or something. And so we could create additional, a richer feature set that takes into account sort of what letters look like other letters in print or in cursive. You could also take into account what letters sound like other letters. So remember that you've got the sort of the error stage that goes from cursive enumeration to computer. We've got the error before that where I'm sitting in my house, I tell the census enumerator my name, and he or she tries to write it down. And whether they get it correctly and how wrong they get it is also another big question. So there's lots of ways that we could, there's lots of ways to count up features like that. And you may increase both your accuracy and your efficiency if we can create a method that has features that account for those sorts of errors. That's a great point. Yeah?
So the discussion so far seems to be sort of how to make the best match for all cases in all scenarios. I'm curious if we should think about tailoring our matching for our particular questions. Seems like many of these scenarios, depending on what you choose, are sort of going to bias your sample towards or away from matching certain people who legally change their name. You mentioned women before, but I mean, men change their name occasionally
Sure,
as well.
sure. Kids change their name when they grow up, and they were there as a nickname as a child. And, yeah,
some people
exactly.
experience change in their sex category, so some people change sex in their race category.
Sure.
So, and I think we've talked, well, you've mentioned that you're not matching on race because of the
Yes, that's right.
involved. But I'm curious if some of these issues are more serious for some problems and some of these issues are not. And if we do really, at some point, need to recognize that the sample that we get is never going to be fully representative,
No,
but we
that's
should
for
be aware of how bad or
Yeah.
whatever it is for
So,
a particular problem.
so I would suggest that actually there's sort of some flexibility in using the supervised learning, the training data set. If when you go to train your data, whether you're doing it individually, you're having research assistants do it, you sort of give them the guidelines of like how we're going to try to make these matches. If you're working with a population that does a lot of if you're really interested in people who change race over time, then you would give your enumerator, your researchers the goal of like, let's build a training set that's totally agnostic on what the race that's written down on, because I don't want to bias my sample one way or the other. Or if you're really interested in matching kids to adults, you might say like, let's be flexible. Let's make sure like that a Jimmy who becomes a James when they grow up, let's consider that a possible match. And bring in additional information. So you can sort of mold your training data, hopefully in some ways, to account for those kinds of problems.
In fact, the way this literature evolved was exactly like that. So it started with applications of like Joe Ferry trying to match a ship record list that he found, and then he decides what variables make more sense for him to match by hand. And then other people doing stuff, and then for example, then in Roy's job market paper, he figured that, actually matching on race is something that might seem a benign issue, but actually, people pass as white, and this might change his conclusions. So it all started with kind of like a specific matching on variables depending on your application, but at the end of the day, like this kind of method, that if the researcher can tell James what he wants to match on, and then the method will kind of work itself out on that.
Both on the training data and then on the features that you use. Like, the feature list I gave you is not exhaustive.
The choice of identifying variable is something that he doesn't, we don't have a comparative advantage to advise you what to do. It's
That's
really
right.
the choice of your, depending on your application.
Yeah, that's
One more
exactly.
thing,
Yeah.
the fact that you don't have a fully representative sample doesn't mean that you need to throw away.
No.
You just need to acknowledge it.
Yes,
Right? 'Cause
exactly.
when you're passing for white, you're saying, what about all the people who lied about their real name or
Yeah.
where they were born?
Exactly.
Like, well, I don't have them in my research, so everything I say
Is
for
going to be
those who
restricted
passed
to
for
that
white,
group.
but, kept their name and history other than.
That's exactly right. Yeah, there's sort of, as long as you can acknowledge that, it depends on your research context. That's exactly right.
Do we have
Yeah.
time for?
We have time.
Could we see the slide with the
Yeah.
the date of birth or year of birth?
Yeah, sure.
Differences within the sample?
So like
The
this-
errors that between plus and minus
this guy?
2, yeah.
Yeah.
And so this is your match sample, and this
So this is just actually the raw data. This is the IPMS. Yvonne can tell us more exactly what this is. This is the 1880. IPMS has created these. So they, for a long time, as you said, they had this full 1880 data, and they created these small match samples from say 1880 to 1900 or 1880 to 1870. And this is just that, the output of that data, and just asking. I observed the guy in 1880, and I observed him again in say 1900. How many have the exact same year of birth? How many are off by 1? How many are off by 2? And this is going to come in a bunch of, like, error in the year of birth is going to come in a bunch of different ways. So, for one thing, the census isn't taken on the same day in every single year. So, some years it's April 1st, some years it's January 1st. And year of birth is not reported as year of birth in a census. It's reported as age. So that's going to already give you a bunch of guys who are plus or minus 1. It's also the case that the enumerator is going to ask whoever's at home, what are the ages of the people in this household? Maybe they know them all perfectly. You hope your mother knows your birthday. But maybe there's a little bit of slippage, a little bit of error in here. And so we just want to account for the fact that like this is historical data. It's going to be messy. And we want to give ourselves some flexibility to sort of, just because you're off by a year, if you've got the exact same name and your name is pretty unique, you're probably a match. And we don't want to throw you away. That's losing too many guys.
Can I talk? So this is people who are sort of primarily, who are the primary link, who are linked on their own characteristics. And when you sort of see the households that these people end up in the 2 years, what you'll see is that, particularly with kids, maybe with the spouse, like the people who are not the primary links, you might see, the error on the wife's age, for example, might be greater. We can sort of see like she's got the same name,
married to the same guy,
married to the same person. So that's clearly the same person. And it's like, well, maybe we could widen that age window more in general and sort of, allow for the fact that some people do report they're clearly the same person, but they're 5 years difference in age. Once you start widening the age window a lot, then you've got a whole lot more competing potential people.
That's right.
Who could also be the same person, and you start, and this is what you sort of alluded to at the start. You're not going to be able to definitively say, well, this is the one same person, because you've got a whole lot of other people who might now be matching exactly on the name because they're within this fairly wide age band. So as soon as you start allowing ages to vary, then you introduce issues with the names, because you've got the pool of people just expands tremendously.
So is that close to?
Yeah. Well, I'm surprised that this only varies from -2 to 2.
And these are the ones. No, this is a funny graph because these are the ones that we sort of. Yeah, these are the ones we said.
This is the guys that
these are the ones we said. These are definitively the ones we're going to take. Yeah,
this is males. Yeah,
Okay.
this is the primary head. No, that's. I mean, like, so in a different context, imagine you're making a link of a sample that does a lot of age heaping. You might want to make the plus or minus not 2 but 5. I mean, there's. Again, this is where we have the sort of flexibility to what your sample is, who you're interested in, and so you can kind of tailor the specification to what you want, just with the acknowledgement that the bigger you make this window, the bigger your training data set's going to be.
And I mean, fundamentally, it gets back to the problem, like, we have to make the identification on these. If we had a sort of a separate list with a gold standard identification number, and then allowed people to answer these questions, then we could truly see like the true variation in the enumeration, but we can't do that.
Yeah.
We have to use these variables, so there's no independence of the enumeration error and the links we're making.
All right, so thank you very much for being here. So I'm going to talk about this joint project with Ran and Roy on basically linking individuals across historical data sets. So let me start with telling you a little bit about the history of why we started caring about this. So in 1996, Joe Ferry, Ran's advisor, wrote his dissertation in Northwestern, and his goal was to study the occupational mobility of immigrants, and what he did was to link the passenger list to the 1850 census by basically manually searching microfilms. So this is of course a very tedious task. So we are very fortunate that now we have the availability of digitized indexes of historical censuses that offer a set of very rich possibilities. So let me give you a few examples of sort of how economic historians have been taking advantage of this data. So with these sicknesses, we can now study issues of intergenerational mobility by observing sons that are living with their parents and then linking the sons to their house as adults. We can also study the long-term effect of childhood conditions because we can now observe kids in their households and then observe them again as adults. We can see how race impacts economic outcomes by comparing, for instance, brothers that happen to be differentially classified by the census enumerator in terms of their race. We can also study the selection and the assimilation of immigrants, and there are a number of recent papers on those. So let me just start by giving you an example of how an observation in one of these data sets looks like. So I'm going to show you an observation from Rand's, Leah, and Katherine paper on the assimilation of immigrants. So this is a paper in which what they're trying to do is to try to study the assimilation of immigrants, in particular looking at how immigrants are able to move up in the occupational ladder and either catch up or with natives in terms of what they're doing in the labor market. So here we have the case of Alexander James. He was born in Wales. He's 20 years old in 1900, and he's the coal miner at this time. So we now search for Alexander James in the 1910 census. We see that he's 38 years old, which is sort of the predicted age that he should have if he reported the age correctly, still being born in Wales, still the same name. We now look at 1920, we see that this person is now a foreman, so this person has moved up occupationally. So this should already tell you, as Shane mentioned, that, for instance, in this setting, matching on occupation is not a particularly good idea, right? So if we're studying occupational mobility, this is, of course, a very extreme and silly example, but there are more subtle instances in which matching on outcomes can sort of lead us to sort of the wrong conclusions in the setting. Okay? So what we're going to do now is we're going to start from two data sets that we want to link with each other. And the goal here, the challenge in linking historical data is that first that the identifiers that we're going to use are non-unique. So we don't have anything like a social security number that will allow us to uniquely identify people. So of course, if we have that, the problem of linking people is basically doing a merge in data. It's a very trivial problem. So we have people like Sean Smith that we are, have Sean Smith in New York. We are going to have a bunch of those. It's going to be very hard, or basically impossible to tell apart who is who. Another issue is that we are also going to have misspellings in names and transcription errors. So this data is going to be quite noisy, and this noise is coming both from the fact that enumerators are going to write incorrect names because of spelling differences in pronunciation, and so on, but also the people that are transcribing these are also going to make mistakes. So these two mistakes are going to compound with each other. We're also going to have something that misreporting in age. So people are going to wrongly report their age. In particular, in historical data sets, we also have a lot of what is called age heaping, in which people tend to report round numbers after age, like multiples of 0 or 5. And unfortunately, we're also going to have all of the above combined and compounding with each other. So our goal is that we're going to start from two data sets, let's say the 1930 and the 1940, and we're going to basically compare records in one data set to records in the other, and our ultimate goal is to come up with a matrix or with a data set in which for each of the possible pairs, we compute the probability that these two pairs belong to the same individual, okay? And let me tell you that of course, if you start from a sample that has 4 observations in the first data set and 5 in the second, there are potentially at least 20 comparisons that you should be making, right? You will be comparing person 1 with person 2, 1 and 2, 3 and 4 and 5, right? So there are 20 possible comparisons. So in this example, it should already be obvious that it's probably not a great idea to compare people that are born in different states or people that are have names that are extremely different from each other. And that's something that Shane's has already talked about. And Another challenge that we have is that we want to develop a method that is fully unsupervised. So this is a method that is not going to rely on a training sample, and this will have some advantages. Is of course going to be less costly because we're not going to have to invest money in creating a training sample. It will be sort of, we think, a bit easier to replicate because we can just give you the parameters of the algorithms, and you should be able to replicate our results without seeing how the array is deciding on things. That of course is going to come at a cost. And the main cost is that we're going to need to impose more structure on the data. We're going to rely on sort of doing distributional assumptions on how these error rates are related to the true matching status of two individuals. Okay? And this is something that James has already discussed, but just for completeness, let me say that our goal here is to create a link sample that is large. We want also the link sample to be accurate in the sense that we want things that we call a match to really belong to the same individual. We want the sample also to be representative of the underlying population of interest that we are studying. And we also want to do this at a low computational and monetary cost if that's even possible. And from Shane's talk, it should be clear that there will be a trade-off between sample size, that is the number of units that we declare as a match, the accuracy, and the representativeness. In particular, of course, if we are linking a lot of individuals, we might end up making mistakes. And if we are using as identifying variables things that will increase the accuracy, for instance, the state of the county of residence, that will increase accuracy, but is going to bias the sample towards people that stay in the same county, right? And of course, this trade-off will depend on the research question at hand, right? So if we are looking at an issue of occupational mobility, well, then matching occupations would be a terrible idea. But if all we care about is to link about goals 1 and 2, creating a large and accurate sample, then maybe matching an occupation is not such a bad idea at the end. Okay? So in creating these probabilities, there will be sort of two separate issues. One is how to compute differences in strings. So this is something that it's not at all obvious in the sense that for age we can compute the difference. With strings, it's not clear how to do that. We are going to talk about the Harrow-Wilker distance. And the second issue is how to aggregate the difference variables into a single probability, right? So we're going to have differences in the names, differences in the last name and in the age. So how do we come up with a single measure that summarizes the likelihood that two pairs belong to the same individual? All right, so let me start talking about the first of these goals, which is to compute a distance in age. So this is the Harrow-Wilker distance. So James will already talk about this. I'm going to be brief, but the idea here is that this is going to give us sort of a normalized measure of the number of edits and transpositions that we need in order to turn one string into other. So economic historians before that, what they were doing is to basically comparing phonetic codes. So you can turn a name like Hannah Williams into a phonetic code that will tell you that Hannah Williams is now called Han Walan. All right. So this is, of course, sometimes a very coarse measure of whether two strings are similar or not. One issue is that, of course, is any standardization is not going to take into account all the possible mistakes that can be made in writing, in turning a Williams into a William, right? So it could be that the A and the M are misplaced, or it could be that you forgot to write the S. So there are many possible mistakes. So any standardization procedure is unlikely to deal with all those simultaneously. Okay. So what we're going to do is we're going to have these data sets, and we're going to turn these two raw data sets that we have into sort of a comparison matrix. Okay. So let's say we had 3 observations in the first data set and 4 in the second. So here I will be only comparing people that were born in the same state. And again, this is basically for computational reasons. This is going to allow me to not have to compute all the string distances that I will need to compute. Of course, with 3 and 4, it's a trivial issue, but if you're linking the full 1930 census to a full 1940, it would be a huge mess to do all the possible comparisons. So, okay, so let's say we have this Sean Smith. There will be 2 of those, so we see that the first row is measuring how, we see that there's no distance in first name, no distance in last name, no distance in age, and that's true for the first possible comparisons. And we see that Hannah Williams and Hannah Williams have a different predicted age, so Hannah Williams, if that's the real one, should be 53, but happen to have reported 55. So this could be either because it's a different person or because this person is rounding her age to a multiple of 5. Okay? And we see that we have a different Anna Williams that has the name differently spelled but happens to have the same age. So we want to sort of first get a sense of which of the 2 is going to be more likely to belong to the same individual. So let me give you a brief note on the Sean Smith of the world, and it's sort of unfortunate that any linking method is not going to be able to distinguish these 2 I's from each other. So there's some research going on in this area on how to sort of accommodate this into the estimations procedure. For instance, some people have suggested choosing one at random and then readjusting the coefficients. Ran and Cawthorne is also working on a procedure in which you're basically using everyone and weighting by a probability of being a true match. There's a paper by Nick Siebert that suggested using the mean. So there are a number of issues with that. We are not going to deal with that in this talk. We are just dealing with the fact with how to assign probabilities given these observed distances. Okay. But for Hannah Williams, well, there are sort of these 2 possible candidates, right? So we would like to get a sense of whether the probability that these 2 records belong to the same person, given that the first name distance is 0, the last name distance is 0, and the age distance is 2, how that compares to the probability of being the same person, given that the first name distance is 0.21, the last name distance is 0.025, and the age distance is 0. All right? And in order to do that, we're going to impose some structure on the data, and in particular, we're going to use a base rule. Okay? And we're going to use, there are 2 key relationships in the data that are going to allow us to sort of estimate these parameters without relying on a training sample. The first relationship is that we know that the probability that 2 individuals are the same person conditional on observing the distance in the last name, first name, and age. Of course, there could be different distances in other variables, so let's just for the sake of concreteness focus on those 3 for now. It's going to be that's sort of what we're after, right? So that's what we want to estimate. It's going to be related by, can be written as the probability of observing a distance given that the 2 records belong to the same person times the probability that 2 records belong to the same person divided by the probability of observing of a given distance. The second relationship is that the probability of observing a given distance is equal to the probability of observing a distance given that the 2 records belong to the same person times the probability that these 2 records belong to the same person plus the probability of observing that distance given that this is a different person times the probability that this is a different person, which is 1 minus the probability of the same person, right? In the data, we're going to observe an analog or a sample analog of the probability of a given distance, right? That's all we observe in the data. So in the data, we're going to observe this matrix in which we have a column for distance in first name, another column for distance in last name, and let's say another column for distance in age. That's all we're going to observe. So we have a measure of these things as in the data, but we know that this thing that we observe in the data is related to the things that we want to estimate through this relationship. Okay, so that's sort of the key relationship that we're going to use in order to get our parameters. And in practice, what we're going to do is to assume that these distances are coming from some distribution. For instance, we can assume that this data is coming from a multinomial distribution in which we assume that all the variables are conditionally independent on each other. So that will mean that we can write that the probability of observing a distance in a first, a last, and age conditional on being a third person as the product of three different probabilities. All right. Once we have assumed a statistical distribution for the data, we can write the maximum likelihood. We can write the likelihood of that data. In particular, we can say, well, what's the probability of observing this set of distances given the parameters of this underlying statistical distribution? And what the maximum likelihood is going to do is to choose the parameters such that observing those distances that we see in the data is the most likely outcome. Okay? Yep.
Do you want to take questions as we go? Or?
Yeah, sure.
So the conditional independence sounds good for, well, actually, no. If it's the enumerator, I was going to say it's fine for the enumerator, but actually it's going to depend on who the enumerator is. A good enumerator will make no mistakes, a bad enumerator will make lots of mistakes. But also, I was thinking more importantly, the person who's reporting, if I'm the respondent in 1910, but my wife is the respondent in 1920, then all of a sudden everything will be wrong on me in 1920 because the respondent has changed. But maybe, is there some, should we worry about that or not really?
We should be worried. We will see that under certain circumstances we can relax that a little bit. Unfortunately, it's something that we need to bear with in doing the method, in the sense that if we are going to allow sort of full dependencies among all the variables, the system is basically not identified. There's nothing in the data that's going to allow us to take into account all the dependencies across all the variables. So that's something that's a shortcoming of the method that we are aware of, but it's we need to impose some structure in order to be able to do this without a training sample, basically.
But some of these things are observed. For example, who is the respondent, or at least head of household, is observed.
Who is the head of household is that will be observed in some settings, right? Yeah. Again, maybe what we could do is to allow, for instance, for dependencies in the first and last. But we are never going to be able to do full interactions among all the variables, essentially. Okay? Computationally, it turns out that solving this maximum likelihood problem is quite tricky. And there's the machine learning people have come up with this EM algorithm that is basically sort of a computational trick to solve this problem that is just numerically hard to solve. So one question that might arise is how it's even possible to do this, right? So you're sort of observing just distances in data, and you want to come up with sort of measures of probabilities of assigning a probability score to each of the pairs. So the intuition of why that is possible is that there's this very neat example from the initial paper that studied the literature on record linkage. That if you have three identifying variables and yes, so that you have three identifying variables and you assume this conditional independence and you do just an agreement-disagreement comparison, then estimating the system, it basically reduces to solving a system of sort of 7 equations in 7 unknowns that is exactly identified. But for instance, if you have a single identifying variable and you have an agreement-disagreement comparison, the system is not identified, which means that there are an infinite combinations of these probabilities that lead to the exact same estimate probability of distances, right? So the system is not really identified. So there's, and that's why we sort of the independence assumption plus having more than one identifying variable is going to allow us to sort of identify the underlying parameters in this. Okay. So let me tell you sort of a to-do list for researchers. So we're going to soon make available the data programs that do this. And this will be on Rand's website. We have a version in R that does this, but economists use Stata, so we also want to make sure that economists can use this. Then there is the issue of choosing identifying variables. So this method is not really informative on that, as in the case of chains, it's not really informative on that, and this is certainly going to depend upon the research question and the information that the researcher has. Then there is this computational issue of choosing blocking variables. So this is basically a step that is aimed at reducing the number of comparisons that you should be making. So some people have used the place of birth is quite uncontroversial to do that, but some people have also used the first letter of the first name, the first letter of the last name, basically under the assumption that those are less likely to be misreported than subsequent letters on either the first or the last name. Then after we have chosen these identifying variables, well, then we also need to come up with a measure of how different these two observations are from each other, and so we're going to need to take some decisions on whether to compute the absolute distance in age, or computing, the proportional distance in age, or just the raw difference in age, how to compare first and last names by using this Char-Wickler distance. Then we're going to estimate these probabilities by using some of the methods that we discuss in more detail in the paper. This will be basically maximum likelihood, a version of the method of moments. And one final step that we also want to do is to sort of check how this link sample compares to the population, and we suggest a number of procedures to do that. Okay, so that's all. That will be what I have to say for now. So yes, I'm happy now to take questions.
Can you maybe go back to the 5 people and just explain?
Here.
Is there some way that you can give a little bit of, I thought you were going to give us one more slide where you showed how this kind of worked on the 5 people, or is that not going to help us to understand what?
So, yeah, we don't have that slide. Let me tell you what. Let me tell you what's underlying the data that is allowing us to do this. Is basically, this is sort of a clustering method, in which imagine that you have 2 identifying variables, let's say distance in first name and distance in last name, so that each of these pairs will be a point in that space, in that 2-dimensional space. So what this method is doing is, we know that the ones that belong to a same person, the set of matches will be sort of closer to a 0. And the ones that belong to non-matches will be sort of further apart from the 0. So all this method is doing is sort of finding a partition of all the points. Okay, it's finding a partition of the points that is sort of a clustering method in which we are sort of trying to split this data into 2 different sort of clouds of points, right? And this is not a conventional clustering problem in the sense that we are assigning, it's sort of probabilistic. So we are not doing a hard assignment to each of the clouds, but rather we are doing sort of a probabilistic assignment. We are saying, well, these 2 persons are 85% likely to belong to the same individual. Right, so what in the data is allowing us to do that is that there should be sort of a clear partition in the data between what constitutes matches and what doesn't. So if we have a totally noisy data set in which people are randomly reporting the names, then this method is going to give you a pretty bad answer. But we think that because of the nature of the problem, people that in observations that belong to the same individual and observations that do not belong to the same individual are going to be sort of quite neatly separated in the data. Okay, that's sort of the basic intuition of why this works.
So just to go back to the Hannah Williams and Anna Williams in 1940, we're going to get numbers like 0.7 on Hannah Williams and 0.6 on Anna Williams.
Yeah,
and
absolutely.
They won't up to 1. They won't add up to 1.
Right.
They'll just be different probabilities.
Right, it will be different probabilities, and yeah, that's absolutely true. And then we are then there are different criteria for deciding which one to choose. So one, we discussed in the paper one possible approach, which is so very similar to what James did, which is, well, let's just pick the highest, and then let's allow for a sufficiently large difference with the second one. That's one possible criteria, but we don't want to talk about this in the talk, in the sense that there are these new methods that are basically trying to incorporate this probability, these estimated probabilities into the analysis. So if, let's say, we have a Hannah Williams with 0.7 and other with 0.5, why not using the two of those and doing some sort of a weighted average between the two? So that's why we think that at the end of the day, it's not going to really be necessary to sort of to settle on which observation we're going to choose, but rather we're going to be able to do analysis basically by using these underlying probabilities in the analysis itself.
Do the probabilities add up to 1? The targets for Hannah Williams in 1930, do those probabilities add up to 1, or are they or not?
No,
Like I gave 0.7 and 0.6.
They don't, right? They do not add up to 1. No, we are not involving that in the.
So what is the meaning of them?
It's a probability.
Because I think there's only one true match.
Yes, but
Yeah.
it's not in your model.
But you don't know what.
But there's anything in the model. There's anything in the model that is forcing this to be a one-to-one match.
So I could afterwards I can normalize it to do that. But
Right.
maybe I'm not even understanding what the probability is. It's the probability.
It's a probability that given the distance that you observe, so it's a probability that given this, right? What's the probability that these two persons, that this pair belongs to the same person? Okay, so it's given that you observe a 0, 0, 0, what's the probability that this pair belongs to a same person, basically?
The issue is like, how do you trade off 2 years apart but the same name with 2 strings apart but the same age? How can you boil it down to one instance? Then, the example that Santi gave with the clustering, if the data was random, if you have 10 people and 10 people and you have 100 potential matches, it will be a cloud. If you know exactly which the 10 people are, then those 10 out of 100 matches will be exactly on the 0, 0, and all the rest will be further away. In reality, what it will be is some distances in first name and last name will be close to the 0, 0, and some of them will be farther apart in a way that you can kind of hopefully can give probability that each of them is a true match. None of them will be 1, none of them will be 0, because we don't know what a true match is, but hopefully will be the closer to 0. It will be like, we'll get a higher probability that this is a true match.
Yep.
So you did it, on your last slide, step 6 seemed to indicate that you might have done some sort of test of actually did hand code? Like, step 5, what does checked how linked sample compares to population? Did you actually do some comparison of the?
Yeah, so this is something that Roy did in his short market paper. I'm also doing in my own research, which is, well, after you decide on what's a match, that's something that you eventually you not with these new approaches of dealing with that, but so that the state of the literature is that you choose a single match. Then what you can do is to take the IPOM sample and see how the people that I'm linking compare to the underlying population. So imagine that you're linking the 1930 to the 1940 census, then if your matching algorithm is right, then the survivors in 1940 should be similar to the people that you end up linking, essentially, right? So, and you can test for that by comparing how these people look, by comparing these people to them in terms of observed characteristics.
But have you actually done it with, either in, with existing data? Have you done it, or is it?
Yeah, we have done it. Yeah.
But I mean, that's not part of the method. That's kind
right,
of
that's not the method.
So
that's
for now, any individual paper that writes things on matching, half of the paper is devoted to what extent is my sample that I generated is representative of the population. By comparing the various cross-sectional stuff to the panel and are the observable characteristics roughly the same? Are people the same ages, the same, things?
Yeah, at the end of the day, what people typically end up doing is to reweight the sample based on some of these observable characteristics. For instance, if you have, let's go back to Sean Smith. So if you have a Sean Smith from New York, it's impossible to match him. A Sean Smith from Rhode Island might be matchable, which means that on average, we are more likely to match someone from Rhode Island than someone from New York, given a distribution of names, a constant distribution of names across states. So maybe at the end of the day, you might want to reweight your sample and give a higher weight to the New York people, because each New York observation is much harder to get. Okay? And if you are doing this with immigrants, you might also want to match on country of birth. The IPONS people, I know they do the matching, they reweight on race, right? So yeah, there are sort of different approaches to sort of, once you have created a sample, trying to come up with something that resembles the population of interest as closely as possible. Yep.
So maybe this is a question for both of the last two papers.
Yep.
Eventually, we're going to do something with this matched data. We'll maybe estimate a coefficient in a model.
Yeah.
So there might be some sense of which there's an optimum procedure for estimating that coefficient. I mean, not just are we worried about changing race, but we actually have a statistical procedure that we're going to apply to the data. Is that a direction at all of these matching algorithms, that you kind of ask what's the best property estimator in this regression? What matching algorithm should I use? Or is this way beyond what we should be thinking about?
No, I think that's certainly what we should be thinking, and sort of how to then run regressions with this data. So I think that the current approach, and maybe change, you have a different view, is that people tend to just choose a unique match and then treat that as the truth. That's the current practice, I think. And there are some recent developments on how to deal with multiple matches, or how to deal with the sort of Sean Smith of the world. What I think is not really well developed is how to deal with the fact that even if you have 5 Sean Smiths, you might not have the right one. I think that part of the question, that part of the aspect is what's more tricky to deal with. And yeah, of course, any regression that you're running with linked sample where you don't have 100% accuracy is going to lead to attenuation bias, right? So we're going to have coefficients that are scaled down by the fact that we are not really measuring the same individual. So there will be an attenuation bias, a measurement error issue. So that's.
Just to give a sense also, by the way, of the magnitude of the problem, if you want, is that the two kind of main weaknesses of all this linking, let's say the traditional way. The first is that you miss half of the population, the women. The second is that even the gold standard of hand matching is in the order of like 20% match rates across any 2 censuses, basically. That's low. This is, and so like, and you know, it's well known that the Rana Bramitsky of the world are different than the John Smith or not, you know. We don't know to what extent the ones you are matched are different, so this is where the whole comparisons. I guess this method at least give you the potential of increasing that match rate.
And of holding on to that error that we
Holding on to
think is going to be
because
important
nothing in the methods of James and in this method make the thing worse. So at some level the traditional method is not at some level the traditional method is a special case where you just choose a very strict criteria.
A specific set of weights.
Specific set of
very well, very specifically specified.
But also on the measurement error aspect, it also depends a bit on the research question, in the sense that let's say that the extent to which you are so the extent that your sample is not 100% accurate will also will differentially affect the conclusions depending on the type of research question that you're dealing with. So if, let's say, you're estimating the effect of a program, but all you care about is the sign of that, it's a different issue that if your goal is to, let's say, count the number of people that go from one occupational category into other, in which if you, let's say you want to do an intergenerational mobility study, well then having bad accuracy is going to inflate the rates of mobility that you observe in the population. But if all you care about is seeing how something affects intergenerational mobility, then the issue is less obvious, because that might affect the coefficient, but you might also learn something from the sign of that relationship.
Or the relativity of the
Right,
you sort of
right.
imagine differencing out across. If you have
Right.
a match that's not perfect across the whole country, then maybe you can still say something about
Yeah.
differences in the relativity.
You will still have an inference problem, right? Though you have a bunch of noise in your X that isn't propagated into your interesting areas.
That's right.
Absolutely. Yeah. No, that's something we should be thinking about. I agree 100%. So,
But at least with the method, with either of the two things we're talking about, generating something like a probability or a score or whatever, that at least gives you something to think about how much noise we're propagating into the inference. That like, if we have all these matches and they all look like scores that are really high or probabilities that are really high, maybe that's not such a big deal. But if we're making a lot of decisions that are sort of more noisy, then we should take account of that.
Can we go back to the assumptions of the conditional independence?
Yep.
So is the assumption here that the chances of an error on, thinking about the enumeration process, the chances of an error on each of these things are independent? So if you have an error on your first name, that's independent of the chance of there being an error on the last name?
we are, the conditional, we are conditional on being the same person.
Same person, right.
Yeah, so we are assuming, that's, so what, I know it's a strong assumption, so we can do some richer settings which will allow some interactions, but as I told you before, there's no way that you can, in an fully unsupervised way, to deal with all the possible, and I think that, if you had training sample, then you can start sort of throwing up interactions between the things, and that will give you, so we'll break up that independency assumption. But here we can't really do that in the sense, because we are relying on it, we are not relying on a training sample, basically.
Let's stop here and take a quick break, and we'll start again in 4 minutes or so.
Josh, and thanks for organizing this. It's been a really interesting afternoon. Can you guys hear me? I feel like this is... Okay. All right, so this paper is literally fresh off the press, so I'm very interested in anything you have to ask about. I'm going to show you a lot of results and a lot of data stuff. I'm not going to say so much about interpretation or what's going on, because I literally finished my tables last night. This is one of those great methods that you get yourself to do something, you send it in and say, I'm going to have it done. All right, so this paper is sort of follow on from some of my dissertation research a couple of years ago, thinking about Black incarceration in the first part of the 20th century. So it's kind of a difficult task to look at because there's not really good crime data before 1940. And so I'm going to use census data and use incarceration as my measure of crime. And one of the big things that's sort of been put out there in the literature, there's one paper in sociology that I'll talk about, is that really the northward migration of blacks in the first half of the 20th century really drove up Black incarceration rates in the United States. So this is just the overall incarceration rate. I stole this off Wikipedia, so it's really blurry. I tried to make my own last night. But you can tell that between 1920 and 1940, just the overall incarceration rate goes up quite a bit. Not so much in terms of the scale after 1970, but if you look on sort of the scale on the left, there really is a doubling in the incarceration rate for all races. Sort of between 1920 and 40. And I think that one factor of that is really moving people from the south, where the incarceration rates were quite low, to the north, the urban north, where incarceration rates were much higher. That's just going to serve to drive up the entire overall incarceration rate in the country. So this paper, what I'm going to do is really ask that, what was the effect at an individual level of migrating from the rural south to the urban north in terms of your propensity to be incarcerated in the census in 1940. And we can do this, so prisoners are pretty rare, and so if you go to a 1% sample and you pull out using the group quarters variable everyone that's in prison, you'll have like 50 people. And that's not very good for calculating incarceration rates, right? So using the full count data is really a lot better to do. And what's been really nice in the last 2 years, after I wrote my dissertation, is that now we've got the group quarters variable to identify prisoners in 1940. And I'm hoping we'll ask Yvonne later about 1930 and 20. But that actually says this person's in a correctional institution, and you can grab all the prisoners in the 1940 census. I'm adding, so I'm going to do a 1920 to 1940 link in this paper, so I'm going to see people in 1920 as kids, and then later on in 1940, see if they're migrated and see if they're in prison. I'm going to add 1910 to 1930. You might think that that's actually the time period where the Great Migration was a bit higher. There's not that much migration in the 40s. But that would depend on me coding the 1930 prisons up, which we'll see if that's necessary. So that's what I'm basically going to do, is just be able to use this full count data to get a measure of incarceration. First of all, thinking about the Great Migration, so most people kind of know this is migration from the deep north wall of the south towards the northeast. Partly blacks, also whites migrated, so I'm going to look at whites and blacks who migrate to the north. The second phase of the Great Migration was towards the west. I'm going to throw out everyone that goes west in my data sets, about 3% of the data. What I'm going to really look at is whether if you're born in the south, do you stay in the south, or do you migrate to the north, and are you incarcerated or are you not once you hit the northern cities. But this was really a migration sort of straight up the country up to 1940, and then the second wave was when people started moving west. So there's a lot out there about why people moved. I'm not going to spend too much time on this. Incomes were much higher in the north. Right, so income was about 75% higher in real terms if you migrated to the north, and that's really sort of pulling people to migrate north. Push factors like discrimination in the south, Jim Crow laws, the boll weevil sort of destroying all the cotton. This made people say, let's up and move, let's go to the north. And there's big literature on what were the effects on the population that actually moved. Who said they have higher incomes. There's this one paper about higher incarceration rates. I'm going to be taking a slightly different approach than he took. This is a sociology paper. And this is actually, ignore that. Some of the stuff about health effects that are negative. One is this paper, Black et al., that says that the great migrants themselves, they died sooner if they migrated. They were taking up bad behaviors, bad health behaviors when they moved north. The reason I said this is silly is I'm writing a paper on that and the slides from that. But the Great Migration itself was also bad for infant mortality. Kids that moved north parents who moved north tended to have less healthy babies when they moved into the northern cities, particularly in the first part of the Great Migration when cities were still very bad places to live. Right? So it's a very mixed story about what we know about whether people, they did better, but they also did worse when they hit the cities in the north. Alright, so this is the paper that's probably most similar to what I'm doing, but what I'm going to do is take a much more micro approach than this paper by Mueller in 2012. What he did is basically look at a similar question: what was sort of the effect on overall black incarceration of the Great Migration? Thinking about people who are living in the north, how are they affected by people that moved in? But very unable to sort of distinguish between southern-born versus northern-born, stuff like that, because he's using very aggregate data, just sort of who's in prison. Right? It wasn't micro data of where people are, where they're from. And he does see that, okay, the Great Migration seems to have increased black incarceration at an aggregate level. What I want to do is look at a more micro data, individual level foundation to think about. An individual moves, how much more likely are they to end up in prison? And then there's some other, basically I put these two up, so these are pretty much the only papers that work on incarceration in the first half of the 20th century, because the data just hasn't been there. I think now that we've got full count census data, we're going to be more able to look at incarceration because it's something that we can actually grab. We can grab big samples out of the census. Yeah.
Oh, I'm sorry, is it okay to ask a question?
Yeah.
So, I mean, there's a, I guess you could think of a spillover too that you might want to disentangle if one could. Are you going to try to do that? That southern blacks and northern blacks are different, but so one could sort of influence the crime rate of the other, or either way, I guess.
So I'm going to compare southern-born blacks to northern-born blacks, and actually that's sort of opposite what you'd expect. The northern-born are more likely to be incarcerated than the southern-born, which
after the migration.
Right. So that could easily be a spillover. I'm trying to get at, could I use some sort of intensity of migration into the areas, and that's very much what the Mueller paper did. Is think about how many immigrant migrants did we get into this area, and how did that sort of increase the state level incarceration rate. I think I'm going to take a more individual level approach of, if I migrate, what's the sort of causal effect of migration on my propensity to be incarcerated. Yeah, you can definitely think that there's my behavior affects others' incarceration.
And so it seems like the aggregate approach is going to kind of mush those together, whereas your approach could disentangle them. And what you said is your migration, on the effect on your incarceration, but also you get the effect on other people.
Yeah. So I didn't think about how I could identify that, but that's a good point. Yeah. I think that's up. All right. So what do I find in general? Basically, as we'd expect, given the other knowledge that we have, that individuals who migrate have a very large increase in their propensity to be incarcerated. About 70%, so it's about 1.6% are incarcerated in the South and 2.3 or something in the North. I'll show you in a second what those numbers actually are. But this is robust too. So the reason I'm going to match across censuses is because I think there could be some selection into migration. People don't think there actually is in the Great Migration because so many people went, and we haven't found a whole lot of evidence of sort of selective migration on income or education, stuff like that. But we do kind of worry that maybe it's the person that is sort of really motivated, is going to have a great job, that moves to the North. Well, they're also less likely to be incarcerated, right? So I might be understating that causal impact of migrating. And so by matching people across censuses, I'm going to be able to control for your birthplace, and by birthplace being birth county, and any household characteristics of your birth household. Right? So what did your dad do? How many siblings did you have? And I'm also going to even have a household fixed effect, where I'm going to compare brothers who moved to brothers who don't. Turns out if you're a brother that moved north, you're still more likely to be in jail than your brother that stayed behind. And then I'm going to see actually that what I think is interesting is that by using that 1935 variable about where were you 5 years ago, I can see that it's actually the recent migrants who are completely driving this pattern. It's recent migrants relative to people that didn't migrate that have the biggest gap in incarceration. It's not the people that have been there for more than 5 years. Yeah.
So is the, if I were born in Alabama and I had a 10% chance of being incarcerated just as a random person in Alabama, and I moved to New York and I have a 17% chance of being incarcerated because now I'm a random New Yorker, that would give me this 70% just because the rates of imprisonment are different.
Right.
Is that what you're talking about, or are you talking about something net of that, the fundamental differences, or are you?
So
I'm just trying to understand what an individual rate of
right, so
incarceration
that's
is.
that's exactly it, right? So I'm going to look at everyone born in the South, right? And then I'm going to say, are you in the North or are you in the South? Right, so there's an incarceration rate within my data of people living in the North, and there's an incarceration rate in my data of Southern-born people living in the South, and Southern-born people living in the North. And that's basically the comparison, right? And so that basically says, the idea in your head is if I move someone from the South to the North, they've got the same probability of being incarcerated. The reason we might worry about selection is that the people that are there are different than the people that stay behind. And so that's what I'm going to try and control for selection and actually not see that it matters at all. Right, so really at the end of the day, you're really just comparing the two different rates, and they're a place-specific thing about the North has higher incarceration rates. I'm going to try and tell you that I think this recent migrant thing tells us a lot because recent migrants are poorer and they're less educated than the people that came before them, and they're more likely to sort of be those ones that can't find the job because everyone, you know, they just came right after the Great Depression, and so they're more likely to not have a job or be unemployed. Does that kind of answer your question?
Yeah, I think it's getting there. Yeah,
Okay.
thank you.
Okay, well, I'll tell you all this in much more detail. I'm not going to spend too much time on this, but if you sort of do a back-of-the-envelope calculation, you can account for about 15% of the increase in black incarceration between 20 and 40, just by moving people from the South to the North. All right, so the data sets that I'm going to use, we've sort of talked about what's available, so Yvonne set this up for me. But the 1940 and 1920 full count data, I've got the group quarters variable to get prisoners, the full population of non-prisoners, so I'm going to match everyone. I'm only going to show you mostly stuff for people that are born in the South, and mostly stuff just for blacks who are born in the South, but I've got everything as well. The nice thing about 40 is we've got education levels, we've got income levels digitized and actually coded up. For 1920, I'm going to restrict to people who are living in their household in 1920, so they're between ages 3 and 15, match those forward 20 years. And I've got information about the literacy of the household head, the home ownership, and the occupation of that household head. This data is very dirty. We've got the full population, but it's a little bit fun to clean. So my access to this is through the MDR, so that was one of the restricted versions that Yvonne was talking about. So I've got the full stuff up there, and I sort of, occupation, I'm just going to break into 4 categories, and there's stuff I can't code, and we're going to put those as other. So in a match across censuses that I can control for selection into migration, anything sort of at that level pre-migration that's correlated with both migration and incarceration, we can then control for in the regression. Skip that now. Okay, so let me talk about the way I actually match the data. So sitting here thinking today or earlier today that somehow I'm 2 years out of grad school and I'm already like behind on matching. So I use a very sort of old school, what they call traditional method of matching, which I personally think is fine. So we'll leave at that right now. So we are going to be this, what James said, I guess, putting certain weights on things and going with it and saying that's the way it works. So we're going to standardize using NYSIS. So phonetic differences are going to be dealt with, but I'm not going to deal with the first letter or any transcription problems. And I'm going to match you by your first name, last name, your age, your birth state, and race. So I have to match on race. I'm interested in blacks. And I'm going to let you be off by up to 2 years, sort of standard, on your age. And I'm actually, there's no reason for this in this particular paper. I think sometimes there's more of a reason. I'm actually going to be a little more stringent than usual. Generally, I just make you be unique on that age. And then you look for you plus or minus 1, plus or minus 2. That gets you a certain sample. A more stringent method beyond that is actually to make sure that there's no one else within those plus or minus 2 that's got the same name, age, race, or sorry, name, birthplace, and race combination. This is most important, I think, for minimizing incorrect matches. So this is one way we actually try and get around the idea that, especially if I'm assigning treatment at the sort of childhood level, I'm not here, right, migration's an outcome. But if I'm sort of thinking about something that varies at a county level during childhood, and I want to see this person's exposed, this person's not, I really want to make sure you're the right person so you're getting the right treatment in that pre-migration time period. Here, if I get the wrong person, I'm going to be making 2 people be brothers that maybe actually aren't. In that sense, controlling for selection is not going to do much for me if I'm just randomly getting the wrong person. So here, I just made the decision I was going to be more stringent. You do it both ways. Get a bigger sample size if you're less stringent, but probably at the cost of getting the wrong guy more often. Here, just want to get the right guy. I've got 170,000 people that match, so I'm not so worried about sample size. My match rates are somewhere between 10 and 20%. And the match rates, importantly, are going to differ by characteristics. Right? So match rates are differ by race. Blacks are harder to match than whites. They're going to differ by prisoner status. Prisoners either weren't enumerated as well, or they just don't pronounce their name correctly, or they don't know their age as well. And by birth state, because those are different sizes. And so to get the correct incarceration rate back out, I'm going to weight results by essentially the inverse of the match rate within these sort of 3x3 cells. To show you how important that is, these are the match rates for the first 7 states that I could fit. For non-prisoners and prisoners, and you can see the sample size on the right, you can kind of eyeball it, and you can see the higher the match rate, so something like Kentucky, the lower the sample size at the end of the day, aka the smaller the population I was trying to match to start with. Right? And so higher match rates are always correlated with sort of a smaller population, because they're just more likely to be unique. Right? So here I wouldn't necessarily want to just use my data set because I'm sort of oversampling from these states that are a little bit different and undersampling from places like Georgia, Alabama, etc. Right? So if I did that and I just calculated an incarceration rate overall, I'm going to get the wrong thing because these states have different incarceration rates to start with. Right? So I'm going to reweight everything based on birth state times race times prisoner status. So again, you can see the prisoners match less often than the non-prisoners do. And the reason these are kind of low is because of that 5-year ban and the fact that I'm being very restrictive on it. These would be about twice as high if I was just going to be sort of the same plus or minus 1, plus or minus 2, and let you sort of have multiple matches in there. But I was very restrictive for whatever reason.
Okay.
Yeah.
Sorry, can I ask, so what are the lag variables that you're using here? Is it motivating the match? So is it that you don't know where they were from when you view them in the later census?
I know the state they were born in, but I don't know the county, right, because they don't ask that. And so I'm going to have county of birth. I'm going to have, I can even have enumeration district. I've got the household you're living in, so I've got all the characteristics about your household. So does your dad read and write? Do you own your house? And occupation. That's pretty much it.
The way you motivated it was that we don't see enough, the sample size is not big enough in a cross-section when you look at the prisoners. A journal might say, well, why don't you just use your cross-section, which has a large amount of prisoners, and just tell us what happens then if you don't have the sort of lag variables to explain things.
Right, and at the end of the day, the lag variables are not going to do much for me, and so you could just use the cross-section. I think that's the problem with any great migration paper, is we really want to control for selection into migration, but there's not much there. So we do it and we say, but I can see sort of what predicts migration. That's an interesting question in itself, and also what predicts incarceration. Prisoners and non-prisoners do come from different backgrounds. I think that's kind of interesting.
You're comparing siblings, you said.
I am comparing siblings, yeah. So that's kind of the,
You need the match.
right, then I need the match sample, yeah. But I mean, I get the same numbers as if I just ran it on the cross-section, right? So good, but
Well, it means it's not about family background or something, which is also valuable, even if you get the same code.
I'm not going to spend too much time on this slide because I think I'm already running out of time, but you can see that basically prisoners are on the right, non-prisoners are on the left. Prisoners tend to have much lower levels of education, and these are migrants versus non-migrants. Migrants have higher levels of education and higher incomes. Income almost doubles when you move to the north. The migration rate in my sample is about 15%, and you've got recent migrants are sort of part of that.
Is this the white sample, the black sample, or the?
These are only blacks, yeah, these are only blacks. I've got whites, but I
So the income, is that, what year?
Oh, I've multiplied by 15 point something to get to 2010.
Okay.
Yeah, sorry,
Yeah,
that's
that
2010
was-
income.
Those people
Yeah.
are pretty wealthy to
Yes.
be affording.
Yeah, they were very small numbers. Yeah, I multiplied by the standard thing we usually do with that data.
Okay.
Okay, so this is an important idea about the representativeness, and so this is what we were talking about sort of with Santi's paper, that you always want to see, am I getting a representative sample of the population? And the answer is usually not really. And you can do various things to deal with that, and I have various opinions about that too. I think that generally when I run this stuff, I usually get something that's selected in a positive way from the population. Right? You need to be literate, you need to be pretty well off, you need to be able to spell your name correctly in order to be consistent across 2 censuses. And so I do see here, I'm fine on migrant status because I weighted everything. They're slightly better off, they're slightly more highly educated. Age, I think, is just random. They're slightly less urban for whatever reason. But, I mean, in general, these differences are not as big as sort of the differences in north-south. And you could think you could probably reweight your data to make this stuff go away if you really thought that that was what was driving it, but I don't really think that's what's driving things. I would say I want to put something in here, when do I worry about representativeness and when would I not? Right, so in general, when we're running a regression on matched data, we're running a regression within the match sample. Right, we're going to compare people that are matched to people that are matched. I would never run a regression with matched people versus unmatched people in the same regression, because you really are comparing 2 very selected different groups of people. But I think the biggest issue when you're thinking about representativeness is that you need your sample, in terms of how different it is from the population, to be balanced across treatment status or across your X variable. Right? So if this table, and it does, and I bring it, looked similar for migrants and non-migrants, then I think it's okay, because I'm trying to estimate that actual effect of the X. If this table looks different for those 2 groups, then you've got a serious problem and you think about reweighting. If this looked different for my different X's, right, so I think about my migrants versus my non-migrants, right, so if the gap between population and match sample was different for my treatment and control groups.
So she's finding, for example, that if you're more educated, you're more likely to be matched, but imagine that is equally true for migrants and non-migrants, then she doesn't have a problem.
Because I'm going to compare the people that migrate to people that don't. And so within my sample, as long as you're consistently off from the population, the gap should be the same. But if one group's like really far from the population and one's not, the difference between those 2 is partly just due to the match. Does that make sense?
Yeah, but one can actually show that.
Right, so I've done it and it looks very similar. I just didn't think you needed 8 tables. But that's what I would say. It's like, yes, I might worry if that was the case. And I think we're never going to be representative in terms of state, right? So that's why I reweighted in terms of the match rates of those states, because you really don't want to get less Georgia, more Kentucky. I guess those states are different. All right. I'm going to skip over some stuff so you can actually see what I do. What happened there? Annoying. All right, so I'm going to write a basic linear probability model. I don't know why I have arrows all of a sudden. Those were not there. Yeah, it's a font. So basically, are you in prison as a function of did you migrate? Very simple, 0, 1 variables on the left and the right. And I'm going to control for education in most regressions, because education is very negatively correlated with whether you are in jail or not. Okay, so here's what I want to get to. Okay, so this regression literally is exactly what I said before. Indicator for are you in prison on the left-hand side, and on the right-hand side, did you migrate to the north between 1920 and 1940? And you can see that if you are in the north, you're about 1.1 percentage points more likely to be incarcerated than if you're staying in the south. And as we'd expect, that coefficient goes up when I control for education, because people in the south have less education than well, people that migrate to the north have more education than those that stay behind. Yeah.
So if one if migrant is, did you go on the Great Migration? So these aren't like, you're not saying, because you could ask if someone who moves from Georgia to Alabama or within Georgia, that could also be a migrant, and does that have a prison effect? That's not what we're interested in. Those guys all get zeros.
Those guys have zeros here. I'm going to look later at inter-regional versus intra-regional migration. And actually, the story is you're migrating. You're migrating to an urban area.
And that's what those things
yeah.
are. Okay.
So it's not necessarily a north thing, it's that you're migrating to urban areas within the south or...
So it's something you can think about it as you can calculate what is the marginal rate of substitution between getting higher income and also higher probability to be in jail.
Yeah, I mean, I think at the end of the day, it's an unemployment story, right? I mean, if you go to the north, yes, on average you have higher income, but you're also more likely to be unemployed, particularly for those first few years. And I think that's translating into higher incarceration a lot of the time. How much time do I have until?
You have 20 minutes.
Okay,
Yeah.
about 5 more until questions. Okay. Alright, so I'm thinking about why is it that this is going on in the north, and so I can think about some other things I could actually look at. Is it just negative unemployment outcomes? I'm going to look at recent migrants versus versus long-term migrants. Is it just urbanization? We can think about migration within the south to other urban areas. I'm also going to look at migrants to the north versus northern-born blacks who haven't had that migration story, but they've sort of been born and living there. And I'll show you it holds kind of for both races, although it's a little bit different, the story that I think is behind that. So I'm just doing a lot of stuff with fixed effects and all those. You can look at the first 2 columns, the numbers don't change very much. But here this is going to be sort of 3 different things. Either you're a non-migrant, you're a recent migrant, aka you moved in the last 5 years, or you're a long-term migrant and you moved sometime before 1935. And you can see that the recent ones are the ones that are really driving this gap. Right, so it's not a very large part of the population. It's only about 3% of migrants, or sorry, about 13% of all migrants are in the recent, and the rest are in the not recent. But they're the ones that are really driving that difference, and it's a much larger gap for that group than it is for the people that have been there longer. And I think this is a story that these people are getting to the north. They have lower income. They're possibly more negatively selected than the people that have come before. And you can see who are these 2 different groups. Well, I looked at sort of pre-migration characteristics and also post-migration characteristics of recent versus long-term migrants. And so people who are recent migrants were less well off before migration. Right? They come from poorer families, actually poorer counties. They're sort of more likely to be farmers than sort of carpenters, or the dads were more likely to be farmers than carpenters. And these later on, they're actually poorer as well, right? So they're about $1,000 poorer on a base of 10,000, so about 12% poorer than people that have been there longer. Right? So I think that they're even controlling for age. This actually is controlling for age. And even if you control for the fact they're a little bit less educated, there's still a gap of about $900. They just had less income in that first 5 years when they get there, and they're not sort of exactly the same person. They're more likely to end up in jail. So this is, again, sort of back to James' question about is it just migrating to a city? So I looked at, do you migrate to the north, or do you migrate outside of your birthplace, out of your state of birth? So I find people either, so they're born in Alabama, are they living in Georgia, that gets a 1. Someone born in Georgia, living in Alabama would also get a 1. But if you stay in your birth state, you don't. And you can see that basically moving to a non-birthplace state increases your probability of incarceration, right? And the reason I think that's happening is that if you move within the South in this time period, you're moving to cities. You're moving from a rural area to a sort of urban area, right? So you're probably moving from rural Tennessee to Atlanta or to Nashville or something like that. I'd like to say, are you moving to a city, not to another state? But if you think about incarceration, it's usually a state prison, so I don't really know where you were picked up. I can't do where you were living, but I can get where you're sort of, if you've migrated to another state. And that seems to be practically equivalent, that increases your probability of incarceration too, because people just sort of live in urban areas have higher probability of incarceration. Yeah?
Do you know what the variation in incarceration rates per capita across states is in this period?
I can calculate it. Do I know off the top of my head?
Is
No.
it much? You have a ball. I'm just curious. I mean, that could also be like the regime of reception could also be playing a really strong, actually explanatory role.
I mean, I don't think there's that much variation within the South off the top of my head. I mean, the Deep South was higher in the early part of the 20th century. I don't know by 1940 if sort of Alabama was higher than Tennessee. But there's a huge gap between North and South that I think dwarfs within South differences. I think these people are different than so someone moving from Alabama to Georgia is very different than the average Georgian because they're most likely to move to a city than a rural area. So I would need like you could get city level incarceration probably, yeah.
Just a quick clarification, outside birthplace is mutually exclusive with moving to the north?
Yes,
Okay.
yeah. You're in the north, you're outside your birthplace, times you're in the south.
Sorry if I missed this, but so is the far right-hand column, is that where you're comparing brothers, basically?
Yeah.
Okay.
Yeah.
And-
So it's beautiful for a couple of things, right? So here, household fixed effects, I get my significance, and you do see that brothers moving north are more likely to be incarcerated. It's still here for there. It kind of loses a little bit of power going forward. So I looked at who's identifying that. There's only, I want to say 3,000 households which have a brother in the south and a brother in the north. So asking a lot of the data to get significance out of that.
Because is it because the match rate is so low, so the odds of finding so you have a household with two brothers, and the odds of finding both brothers in the future is then like 0.1 times 0.1, or?
Well, no, so there's a correlation between finding the brothers because of the last name. Part is just because incarceration is so rare, and migration is not that common, and so I need variation in incarceration status times variation in migration status to get a gap, right? And so you're getting down to tiny.
Could you do something like between county and household, like enumerate? I don't know if enumeration.
I have an
district or
enumeration
smaller
district. I
counties.
just ran out of columns here, so
Yeah,
that gives
or
me a
even
very
like
similar
census
thing.
like within like 10 manuscript pages or something.
Yeah, so I
crappy measure of paper.
did manuscript page
Sure.
before I had a household ID to deal with, and that's a lot better.
Okay.
So I get a lot more significance there because I think I'm matching more
You get a
people.
lot more power. Yeah.
So I'll probably throw that in and say these guys at least grew up in the same neighborhood, so we'll call it a neighborhood fixed effect.
Sorry, just one quick follow. Could we see the previous slide again that showed the R squared? Because, okay, it's a similar story, but the R squared is so high, so you're in a bad family and you get whatever, that kind of thing. But here still we see the significance on this variable.
Well, the R squared is just high because there's a lot of families that it perfectly predicts, right, that are not.
You're in that family, you're going to jail.
Or more likely you're in that family or not, just very few. But yeah, there could be, there's a couple families where both brothers are in jail.
And there are also many families in which you have just one.
Yeah,
Just one guy
right,
and
so
one
it perfectly
person.
predicts, yeah. So the R squareds are really low as we kind of expect in our linear probability model, and then all of a sudden it's high because,
I have more of a mechanism question than
Yeah.
a question. So I'm just curious, is there a difference in like, I'm just thinking, are recent migrants coming from places, they're coming later because they're coming from places with more like racial violence and like maybe lynching, so that they had a more different justice system that they grew up with, and so there may be a way to like think about like.
Yeah, I can definitely look at that. I mean, so what I did here is I just put in a county fixed effect, and what did I say? The differences basically go away between recent and long-term migrants in terms of farmer versus whatever. And so that is, they're coming from different places. It's not that they're coming from different households within the same counties. They're coming from legitimately different counties than people were from the previous time. So I could look at which counties they're coming from and get more on where they came from. So definitely coming from more rural counties, and so that's probably it's a different type of migration. I mean, it's a little bit weird because this is 1940. I mean, the Great Migration in the 1940s wasn't very large, and so these guys are a little bit strange compared to the people that would have come pre-1930.
I was just thinking there's like the Gabe and Wright story about the South like becomes part of the rest of the country because of the New Deal and the federal government finally coming in and trying to force things on them. So I'm kind of wondering if the people who are moving during and after the New Deal are partially different because they're from places they're from which they are free to move now, because maybe they're more racist, but like the federal government has come in and said, no, really.
Oh, yeah, I can definitely look at which counties are and correlate it with lynching or any sort of racial
But
identity.
the effect of the place that, the effect of being a new person and not settled and getting picked up and,
I think that's a lot of
like
it.
there's all kinds of reasonable causal explanations for the new migrants being much, not only criminal in their behavior, but also in their chance of being caught and getting sent to prison and all that.
Yeah, and I think I can have suggestive evidence of who they are and where they came from. I don't know if I can put that in the regression.
Another nice thing that you can have on your survey is you can compare the coefficient, without the brother fixed effect and with the family, with and without the family fixed effects, to see how much of it is a selection across families and how much of it is selection within families, kind of thing, like we do in the.
Yeah, I just don't see a whole lot of movement except for there.
Yeah, that's the one.
Yeah, so there it does go down, right? So you could say, yeah, so I basically sort of argue in the quasi-paper that's written that I'm controlling for selection across families, and so that difference between those coefficients suggests that there is some selection across families if that was significant. The fact that it goes down means they're slightly different, yeah. I guess I'll just, alright, let me say two things and then we'll shut up. Okay, so this is actually, I think, something I'm not quite sure what to say about right now, comparing, so the first two columns compare southern-born blacks to northern-born blacks. Northern-born blacks are much more likely to be incarcerated than southern-born blacks living in the north, if they're not everyone staying in the south. But it's not true for whites, right? So whites are migrating as well to the north, and I skipped the slide that says they have a higher incarceration rate in the north as well. But I'm not quite sure what to make of that story, because here you see that sort of relative to the blacks that were born in the north, moving in there, you're not quite as likely to be incarcerated, but you're much less likely than someone that was born there. Right, so it's not necessarily just a story of, hey, these cities are, you're new and you're getting thrown in jail. There's something about the two different groups, which I think are very different groups in general.
Could it be that you're involved in criminal activities, then if you do one crime every week, so that if you have spent more time in the place, maybe you are more.
The incarceration rate isn't just a function of how much crime is committed. It's a
Oh.
function of how much crime is committed and how policing is done. So I wonder if you have you could look at state budgets or something and see if there's any kind of reaction to the fact that black people are moving there. I mean, that might, honestly though,
I think that's sort of a lot of what people are sort of arguing that, this could either be that people are moving in and it's increasing the incarceration rate of the northern-born blacks because they're also getting sort of higher discrimination and being sort of rounded up at similar rates for nothing.
Right, the police budget is going up.
Right. That's a lot of what sort of the Great Migration incarceration story is. Yeah. Anyways, okay, let me just, yeah.
Maybe another way to read that is that migration has an effect upon individuals which increases the propensity toward crime, but people who are migrating northward are moving into a carceral regime which is much more favorable towards blacks relative to whites, right, as compared to the South.
I'll have to think about that. Yes, I think. Yeah. Maybe with that. Let me just
Let's
wrap
let
up.
you wrap up
Yeah.
and we'll have still some time for discussion.
Okay, yeah, so I don't know what to say except that I think this is a story of not just a discrimination story, because it's the recent migrants that are really the ones who are more incarcerated. They're moving to cities that are holding lower paying jobs and more likely to be incarcerated than those long-term migrants. And that I think you can do sort of a back-of-the-envelope calculation that you've had a 1 percentage point increase in incarceration of blacks between 1920 and 1930. The size of the migration can explain about 15% of that change, or about 0.15 percentage point increase in that. It's not everything, right? So that's not the whole thing that's driving it. I think there's more going on in cities in the north as well. But this is one factor which sort of explains that increase that we saw in this 20-year period. Any other questions?
Okay, so we have about 5 more minutes and then we'll reorganize into our discussion. So let me just start you off here. You said you don't care about using any fancy matching. Can you just say a comment for this research project? Why is it that you don't care about, why is this all fine? Is it because the other problems are so large that it's not worth spending your time on improving it, or is there something unique about this? Should we all not care?
Okay, I shouldn't have said not care. That was saying saying I'm lazy.
fair, I think these methods that we talked about today are not yet used so much by applied research. Most applied research is doing exactly what Katherine.
So let me be a little nicer about that. What I meant is, I think that I'm not worried about match rates being high because I'm using basically the full population. I would always like higher match rates, but in my sense, I really like to minimize the probability of a false positive because I really worry about attenuation bias and a regression if I've got the wrong guy. And so what I think is that for me, having not run all these different methods at the same time, they're all very computationally intensive, the reason I use this 5-year band and I'm really strict and you have to be very unique is that I think that minimizes the false positives at the very large trade-off of having a much lower match rate than maybe if I was a little more flexible about that. So I guess that's what I mean. I haven't done the other stuff, but for the moment I've been using this and I think that I'm happy with a low match rate at the cost of getting the right guys.
The person who's in prison, born as Joseph and he's now in prison as Joe.
I will standardize first names.
There's
So they'll be the same person.
some amount of all that.
Mhm.
So you're not worried about the kind of criminalization influencing, I mean, that's where I would get
So I think
scared
it
about the matching here, is that the
does.
matching and the crime are very much,
Yeah.
even the reporting in prison, is the prisoner doing the reporting of what his name is?
Often, no. Often it's the warden that will be the one that reports it for the whole.
I think
As far as I
that
know.
some prisons like basically provided their register when the
Yeah.
census came around.
Yeah.
I've been doing some stuff with the Minnesota prison, but with the prison registers, you really see, and this is, sort of doesn't eliminate the problem.
Yeah.
Like the names are an issue, because you'll see Joseph Smith, also known as,
Yeah.
and I mean, that's the, I don't want to come to you on it, but that's the
Yeah.
hidden issue with
No, I know, and they
this,
have like names and quotations, and you're like,
Yeah.
that's not your legal name.
Yeah.
But I would hope, if it is from the prison register, hopefully they're putting their legal name into the census
Yeah.
whenever possible. But I think that's one reason that the match rates are lower for prisoners than they are for non-prisoners, because they're changing their names, they're using more nicknames that I don't standardize correctly. Don't know what to do about that except wake them up a little bit so I get back to their incarceration rate. Prisoners are apparently they're annoying. Difficult operators. Any other?
Is there a federal versus state prison? Can you distinguish that in the data? And
Yeah, it's so nice with group quarters. They've got
Step
it.
the name
like,
with a, yeah.
Okay,
No,
so you know
there's
whether
that.
it's a federal or a state. And you know,
yeah, so
you
they've
can
got
guess, like,
jail, federal, state.
will that help
convict
you do
camp.
something about like the severity of the crime? Is it really
Yeah.
broad level?
So I can throw out jails. Jails are often you're just there overnight or you're there for. Yeah. I mean, I don't think there's that much of that because I mean it's one point in time, right?
Yeah.
So all the people in jail are probably not just there overnight. They're, I think in the South especially, the average jail time is like a year in the county jail. So it's not just that.
If you're there for like 2 or 3 days, you should be, your family should be reporting you, like under the rules of the
Right.
census.
Okay. Your usual.
Yeah, it's your usual place of residence. So,
Okay. So
but
they
if
might
you're
be
there-
showing up twice then.
Maybe.
It's interesting.
So maybe you want to read your,
Oh, I don't
here's
have
your questions.
my questions, so I thought you circulated these. So how do you, my sort of big question is, how will complete count data change the kind of research questions you ask? That's, and what will be the sort of the impacts of that on the things we can find? What things can we now know that we couldn't know with samples? Throw that out there.
I mean, to me, the one thing that is similar between this and big data in economics in general is once you start to have such large data, it's no longer about detecting, it's no longer about the power of detecting a statistical effect, so you don't worry about standard error so much. But what it allows you is to have like many little experiments like that, because now because now you can see brothers, one of which was moved and was imprisoned, and the other one was not, and that's something you can only do with large enough data. So it allows you more questions that they are kind of getting closer to experiments, if you want, and without worrying.
You can share that.
Oh, sure.
This is, I think, just so that we have a record, so that people who watch this will be able to hear your answers.
Yeah, we should restate the question also,
Yes, please.
for the record. So I'll answer, I mean, just so what Katherine was talking about now is the prisoner population, you can't do that in a 1% sample or 5% sample even, that you need the 100%. So it's not just prisoners, it's all other groups that are especially small. Or if you're especially interested in some natural experiment that happened in one town or in one county, you can get everybody in that county and everybody in the 5 counties surrounding it and do some really cool economic history or economics or sociology or whatever. But before, if you had a 1% sample or 5% sample, you just didn't have enough density of people in those places to say anything meaningful about this. And so now we have enough people, especially then we blink it over time. Even if a match rate is 50% or 10%, you need, no matter what your match rate is, if it's not 100%, you need a big enough sample so that your sample doesn't disappear by the time you get to the outcomes.
I think less so than other people in this room, I'm doing less applied micro, and one of the things I'm interested in is doing macro with the micro data. And so it's really nice to be able to say, like, if there's a change in credit conditions in the Great Depression, I can then actually build up what happens in heterogeneous groups, by the 1940 census or something. So there's a way to actually, which is something macroeconomists are trying to do. So if somebody wants to do history, it's nice to be able to say, but wait, stuff happened in the past, and we could use it.
I think one of the main motivations for the small number of projects we already have here is the time dimensions. We talked about the size dimension, but that's why one of the motivations for doing this Census workshop was because people are very interested in change over time or effect of conditions at one point in life. So sociologists like to call life course perspective, and of course population research is always criticized because we have these huge cross-sectional samples, and we're doing synthetic life courses, and so that opportunity is, I think, a big motivation of a lot of what people are
doing. What's exciting for me is the possibility of, with a full count data, of being able to establish kinship linkages. That you can't do, and it's related to Josh's point, is that since you can now track people over time potentially via matching techniques, you are no longer, in theory, bound by the household boundary restriction in terms of tracking family members. And so in that regard, I was actually wondering if there have been advances in methods that are trying to maybe automate kind of tracking not just the individual over time, but the individual's kin over time.
So cousins fixed offense. The economic motivation, but if you want automatic construction of genealogies must be something that's happening at Ancestry.
Yeah. I mean, so if you have a hammer, why not use it? So let's say you observe the household in one generation, and then you find all those people in the next generation, and now you've got siblings, and now you find their kids in the next generation, now you've got cousins. But that's all sort of, let's do the individual linkages, but just then build them together. There's probably more clever ways of thinking about how we can reconstruct cousins or kin in other ways, but I don't know.
I think if you're starting from the census and you're not bringing in this external information from the family trees, you really are sort of doing this sort of chain linkage across time and finding the individuals. And I mean, my God, the data management issues of keeping track of those generations, simple in theory, in practice, challenging, I think. But no, I've heard people talking about this as something they want to do. So.
The other thing that we've been very interested in is the actual name variables themselves, we think are an important new dimension of characteristics of people that can be exploited in a lot of ways. So here we talk about matching on them, but the variation in names given, some of the papers have looked at that specifically, but we're seeing that in all kinds of dimensions, particularly the value of children, the thinking of parents at the time of their children, the value they're placing on the birth, and the meaning they're placing on the birth is, we think, an element of, from an economic perspective, human capital investment by the parents, but it incorporates a lot of things, and it's a new, the fact that it's textual is giving us a whole set of questions that we usually don't, analytical problems or challenges or opportunities that we didn't have before. So we certainly have, the analogy I use, instead of having kind of one qualitative interview of 1 million words, we now have 1 million qualitative interviews of 1 word, but it's the same, it's textual analysis as meaning.
Sometimes an initial as well. One of the things that I've sort of noticed, and I think your use of the page as the sort of contextual information is people starting to really think differently about how we measure the sort of social context around a person, and this can obviously be combined with the record linkage. So you take the social context they grew up in and trace them forward and see what happens. Previously we relied on Michael Haynes's file of county level information, state level information, sometimes we have city information. Now we can recalculate that at an individual level and sort of vary the sort of size of the neighborhood. Like, is the neighborhood the page? Is it the enumeration district? Dave Hacker and I have a paper where we're looking at, which is going to be in demographic research next year, where we look, is your mother-in-law potentially living next door if you're a woman, and does that influence how many kids you have? And we start with, is she next door? And then widen the window, and it turns out that, having your mother-in-law, because we're just using the names, and it's really a potential mother-in-law. Actually, you have more kids if a potential mother-in-law is living close by to you. For better or worse. That's just... I wish I could do that. So I think, and this sort of speaks to the kinship thing as well, although we can't sometimes make very definite linkages because they don't enumerate your relationship to your neighbors, we can start to make probabilities of, is this your mother-in-law? Are there people within a sort of a range of houses with the same last name? So I sort of throw that out there as ideas you can explore. It's computationally intensive to recalculate these statistics for every household, but it's can add a lot of richness to where is somebody living and who's near them.
That we saw a few weeks ago in Stanford talk on sort of measuring residential segregation at a much finer level than was sort of possible, looking at how, the race of the person that lives next door to you and seeing how the propensity of getting some of the same race was changing over time and across space, that is really literally not just looking at very aggregates or sort of 1% sample where it's very unlikely that it would have neighbors, basically.
That relies also on the use of the fact that, in the 1940 census, you actually have exact addresses. Or like more like, so then you can see segregation, more than just in a city, but rather in a street or something.
Yeah, so so the addresses are there for a lot of 1940. They're there for a lot of 1930. You get into rural areas, and they're not as good. But certainly in cities, and you can go down to fairly small cities, you're getting addresses. You'll find yourself, if you get into this, looking at old maps, because the addresses are, not intuitive. If you hit a city with a grid system, that's great. I invite you to look at the addresses around here and try and work out the actual location of adjacent numbers. Curves and hills add challenges.
One question I had about the matching, when I heard your initial talk about in MPC, you're going to be doing a very narrow, strict match and a broad match. Is a way researchers can proceed is we kind of do our analysis on those kind of bounding two extremes, and if our analysis comes out the same, then we can say, great, we're done, we don't have to worry about matching, or is that going to be kind of a shortcut in the future? Or are the people who are working on these more refined, problem-specific algorithms thinking that, no, we're actually going to need, say in 10 years, we're really going to be demanding that each matching project have its own matching validation, justification.
Okay, so I guess what I think that the literature on matching needs to go, one direction would be in terms of just testing these methods against each other, and possibly against some sample that we know is correct. I don't know if that means simulating data and then trying to introduce noise and see if how the different ways deal with that. And also I think trying it on different populations and just comparing the things on different populations, right? So we know blacks are harder to match. We know like different areas are harder to match. How do these different methods actually do in terms of both accuracy, match rate, because I think there's a big trade-off there. Before, maybe that's the paper that needs to be written is sort of in different situations, what's the sort of standard match procedure that's probably going to give you the best outcome. I don't know anyone that wants to write that paper, but I think that's kind of like going at it different ways. I think putting it all together and saying if we could test them would be.
Is the IPUM's min-max going to provide a broad span of the possibilities, or not really?
I think so. Well, I hope so. I think that the sort of the loss function for your true positives. What is your how many false positives do you want in there? That's going to differ a little across applications. I think our goal is to have something that's pretty good for a lot of applications, but I mean, as you've heard here today, some of the really exciting possibilities come from bringing in external data sets, and this gets back to the sort of the small small population. Suddenly you can take a school register or a hospital and you can find all those people in the census, and that's I think always going to have to be a little bespoke how you're doing it. I think that I really like James's paper. We're applying the methods that he's using to find women from a modern health survey where they had their maiden names. These are again people from Iowa. That's I think coincidental in some ways. We're both working with Iowa data.
State with good data. I think
state with good data. It's not entirely coincidental. But we've found that to be working really well. So I think that there is hope for some standardization of the tools and the programs.
Yeah, I think and so I would say that if you're going to do something where you're linking between two censuses, then probably whatever sort of standard stuff that IPUMS comes out with, whether there's a minimal and a maximal version, then it makes sense to take that because it's off the shelf and someone else has tested it and told you about it. It's replicable. But yeah, I think there's a huge world out there. Like eventually there's only so many papers I think that can be written matching one census to another. Maybe it's but there's a huge quantity of data out there that's not a census, but would benefit from being linked to a census, or that you could do something really interesting by linking it to a census. And yet, for that, you're never Minnesota's not going to give you those linked data sets.
And I think that it really comes from two sort of sources. One is the huge amount of manuscript social science and administrative material from the early 20th century, with the sort of the great growth of the federal and state governments, and things like World War I records are an example, and then particularly with the 1940 census, the post-war growth in social science and all the data that has been created since World War II. People who were alive in 1940, a lot of that I think can be linked back to 1940, and then then we've got get their parents and we can find them. those are the two sort of sources that are going to be linked to the complete count census data from outside of it, I think. So go looking for that data.
And some of it is already started. So John Parman, for example, has written this paper where he matches like World War I records and like to the census, and I think Marta is doing some of that.
Yeah, she's doing civil registration, and so basically bridging that marital divide that happens with women who change their names, which was most of them. Yeah.
You know, it's a subset, but it seems like the Union Army data set might allow some external validity testing here, that you've got white males that they have claimed are sort of representative broadly of at least the Northerners. Another 7 years too, we'll also have Social Security records for 1950 and 1940 that can be looked at with these two censuses then that are linked.
Yeah, I think that would be very useful if there is a data that you know is 100% correct and you know exactly how to match it, and then you run the various methods and you see what sample you generate where you know what the truth is, then that would be very useful.
You know, the early Social Security numbers, I think, I talked to Tim President, he said he used to work in some economic bureau, and the early data is not that good because wives used to use their husband's Social Security numbers and various kind of things like that, so it wasn't as good as today.
So I think there's some initiatives now to move forward from 1940 up to the present.
Yep.
Does anybody know enough to talk about this, just to let people to know what's going to be, I guess this is 5 years out maybe, or something like this?
So the Census Bureau is putting this is, you can, if you have access to a Census RDC, they'll be sort of putting the pics on them so that you can then find them in other Census RDC sources. So if you're in the 1940 census, then there's PIC is on the Medicare data as well.
Can you repeat what PIC is?
PIC is the personal identification key for at the census. I was trying to remember the acronym. So that's largely been done sort of, we're working a little bit with the Census Bureau because it's got to be done. I mean, you could talk a little bit more too.
So right now they've done 1940 to 2000, 2010, and we're now, it's a joint project with Stanford and Census and National Academies of Science where we are digitizing the 1990. So right now everything's been digitized except for the person's name. And so we hope to add the 1990 to that. We're in a pilot project now, and then we'd like to add this PIC to the 1990, and then you could link it to 1940, and then also going forward, and if we can do it for 1990, we would try 1980, 1970, 1960.
So these are Social Security number links?
Yes, they're unique person identifying links.
And you said it's without the name, but then we can go to 1940 and get the name.
Well, no, so what we're doing now is we're adding names. Yeah. And then we want to essentially assign this personal identification key to the 1990, which then, because the census has already added to the 1940, and they have added, and it's on all more modern data, and then you can link over time.
So the issue with 1990 is names were written onto the form but were not transcribed into the electronic file. That's right. Whereas for 2000, I believe they were.
It was transcribed. It's still handwritten, but it was in 2010. They're all handwritten, but they were transcribed at the time. 1990 was never transcribed.
Yeah.
And so yes, it's on microfilm, and we're trying to transcribe it. And so that's actually a question I have for the group, if I can.
Please.
So we are using software to digitize the names, or we're going to use some optical character recognition software. And I'll maybe use an analogy. So let's say you could, the 1940 was mostly hand transcribed by Americans, right?
Chinese.
It was Chinese. So that's the question is, let's say the Chinese, do you want an American transcribing or a Chinese person who doesn't know American names? And so if they see John, an American is going to say, oh, maybe that J looks kind of like a T. An American will say, oh, Tan isn't a first name, John is a first name, so I'm just going to assign that John. But a Chinese person might assign T-O-H-N, because the Chinese person doesn't know. So for linking purposes,
but let's say someone actually does have the name Ton, T-O-H-N, and that is actually true. Or, for linking purposes, do you want, essentially tied to a dictionary and say, an American who knows, oh, it's probably John, versus a person who has no dictionary of American names and just says, oh, this character looks like a T, so I'm just gonna say it's a T. Which, for linking purposes, which one would you prefer?
I don't quite understand the question. You're saying you're producing a data set and you're choosing how to do it, or you have two data sets and you're going to link them?
Well, then we want to then link, your 1990 name, and find out who, find you in 2000. So we need to be able to, find out, link you longitudinally. Do we, for linking purposes, do you want the name to be whatever it looks like on the page? Or do you want it essentially tied to a dictionary and say, well, it's most likely John?
So this is a little bit like matching, like
normalizing
the nicknames.
For example, the yarrow,
I think what ideally you would like the whatever was reported, and then use these measures of string distance, because you might get that Ton and Sean are two different guys. So by throwing away that information, you're
so you would say use whatever it
so
looks
basically,
like.
so you have the string algorithms will tell you, is this one string apart or two strings apart, and how to think about it. Then you can make your own decision about what makes you confident.
Whether it's allowable.
Yeah. If you say I really only want it to be perfect, or 1 to 2 strings apart is fine for me. That's kind of like maybe a judgment call.
There might be people that call themselves Shawnee consistently across time. And a dictionary will call that guy Sean, but maybe the fact that this is Shawnee, that
there's information.
There's information, so you'd rather have the whatever it looks like on the page rather than tied to a dictionary.
That said, I mean, you'd want to, whoever you have, you'd want someone really good at reading cursive characters.
Well, we're going to have software do it. So the question is, do we get the software vendors the dictionary of names? Or do we just say, you give us your best guess at the squiggles?
You mean like letter by letter?
Yes, letter by letter.
Yeah, because you can imagine there's some, this is what people do when they sort of take like old data, like an old book, and to turn it into text. A lot of them get better results when they use a dictionary because they know some sort of 3 letters predicts what that 4th letter is going to be. But with names, I don't think that we get the same value from sort of forcing people to have standardized names. It's certainly true within last names. You wouldn't want to give a dictionary of last names because I think the variability is just too big. You couldn't really have a dictionary for that. I don't think, but I don't know.
Well, I mean, Social Security Administration has a dictionary of last names
for
anyone who's ever had a Social Security number. So we had,
That's okay. That's fair.
Just on the example, the ancestry data entry. I mean, they've had a lot of experience now, and so we're not seeing a lot of tons in there. I mean, where it's a fairly standardized cursive script.
Isn't it double entry? Is there a fair amount of double entry?
Fair amount of double entry, yeah. Which isn't to say that with sort of less usual strings, you might be getting issues like that, but for the most
that's where you let the string compare, do the work
where it's really messy.
I imagine this isn't feasible in any way, but I'm now kind of curious. So if you know the page that the record comes from, is it possible to look at the page, like if you have 2 100% or whatever close matches, and you think it's one of them, but probably not both, is it possible to go to the page and look at the handwriting in 1930 and 1940 and say, oh, it really is record A because it's Ton and Ton that's also John and John, or is it?
Within the Minnesota data, there's a field that is the basic. I don't know if it's a link to the Ancestry record or
it's a URL.
It's a URL. So it's straight to Ancestry.
It's a different enumerator writing. You can't do it by handwriting, but you can. If you're interested in finding a particular high school class, you can spend a lot of energy looking at the manuscripts of the 28 people 280 people.
Is this a personal example? Is this a personal example, the high school class?
Okay, I think this is a good moment to wrap up, so thank you all for a wonderful meeting. Thank you everyone for staying, the bitter enders for staying to the bitter end. And
Very sweet.
I hope this is a wonderful kickoff to many future collaborations. I hope everybody got at least one research idea. We'll be credited. Thank you to
Thank you.
Thank you for organizing.